Another day, another nickel. Several nickels. I forgot to close my blinds. Oh no, it's doing the thing where you can't close it more than halfway. Well, I'll just leave it like that for now, because I don't want to get up. I'm just waiting for Unity to load first. Okay, got that up. Now let's get our scene set up once again. Let us turn on game dev knowledge. I've tried to define the player controllers that I saved. I have the, I probably should change this one, but first person, third person for car, and then, then we have our top down for ball rolling as well. All the different player controllers. I wonder if we'll even have a player controller on this one, since it's just a clicker. A cookie clicker. But, let me pop this stuff up. Boop, boop. Stream and a stream and another stream. Turn that over onto Unity Learning. Lower this down. No. Okay. Unity Learning's up. That's up. I don't have our scripting tool up yet, because we didn't make a script yet. So, take a second to do that. I haven't started the project yet either, though. This says it should be in project. Is the camera just looking at the ground? Oh. Huh. How does this work? Oops. I accidentally just duplicated the camera like 50 times. Are these little dots actual objects? So wait, is the camera just looking at all of these? Ah. It was a plane, so it wasn't showing. Unless I was in front of it. I'm dumb. It was just a plane. Planes don't show if you're looking at them from the opposite direction. They do. That explains a lot. Okay, so our course library, we don't have any scripts or anything yet, so I'll definitely have to make those. But let's load up our course first. Pick up where you left off. No. I won't. I won't do it. Okay. We already looked over the introduction, so I'm just going to go to Clicky Mouse. I looked at that already too. Free project and switch to 2D preview. 2D view. Okay, I know how to do that. Okay, nothing's changing there. Okay, it's in 2D. got that stuff in there, click the 3D icon, change the texture and color of the background, and color of the borders, optional. Okay, well, can I just change it here if I want? Probably be more fun to just like shift the color about or something, but I'll just let it go for a bluish color and make our maybe that wouldn't work that well. Got like an orange. Not terrible. I feel like I want something a little more vibrant. Yeah, that looks okay. Okay. Done. Create good and bad targets. Okay, so we will go over this because it has making a script and all of that, so let's get into it.
Now, the first thing that we'll need for this little game is 3 objects that we're going to collect and then a bad object to avoid. So we're going to go into our project window. We're going to, under our assets folder, expand our course library. And then in our course library, we're going to expand our props. Now you can see we have a bunch of different options here, from bad things we don't want to collide with. We have different balls we can use. We have food. There's other types of things. So I think I'm just going to use some of these other objects here. So I like the look of all of these different crates, so I'm going to go and drag them into my hierarchy. And you can kind of see they're stacking on top of each other, so we'll just go and we'll use our move tool. And we'll just drag them onto our scene so we can see them. And then we need a bad prop to use, so we'll go into props, bad, and we'll just click and drag. I'll use a skull as one of my bad props that way. It's very clear which ones are good, all of these different crates over here. And then we have our skull, which we definitely don't want to press. Now we're going to rename all of our props so that way it's easier to manage them. So we'll name the skull and we'll just make this very simple. So we'll call this bad one for the first bad prop. In our crate, we'll name this good 1. So this is the first one. We have good 2. And then our last cube will be good 3. Now, on all of our props, we actually need rigid bodies and box colliders. Because this game is going to be a bunch of objects being thrown up in the air and then falling, we need the physics for that. And then we need colliders because we're actually going to add triggers to each of these boxes as well. So I'm going to select the first box, and then I'll select the last item on the list. And I'm just going to add components. So I'll add a box collider, so hopefully it works on all of them properly. And then I'll add a rigid body. So now we have box colliders and rigid bodies applied to all of them. Just make sure they work properly so you can see the box looks pretty close. Cube also looks good. That one looks good. Let's see what happens with the bad. Yeah, pretty well lined up. Now what we're going to do is in our assets folder, we're going to right click on it and create a new folder. And this will be for our scripts. And then in our scripts folder, we're just going to make a script called target. And then we're going to select all of our different objects as well, and they'll all use the same target script in general, so we don't need to get very fancy with this. So now you can see they all have the target script applied. Now in our assets folder, we'll create a new folder for our prefabs. Now we're going to take each of our different objects and we'll drag them into our prefabs folder. Make sure you create original prefabs. And now, since we have all of our prefabs, I'll just go and delete all of these objects in our scene now, because I don't think we'll need to edit them much later, so delete, and now we're good to go. So what you're going to do is you're going to go into your course library folder underneath props. You can pick a bed prop that you're going to use for your game, and then choose 3 other props. They can be balls, they can be food, they can be any other kind of prop that you want to use. Make sure on all of the props you add a rigid body and a collider. And then just make sure that the collider is properly lined up with the actual object you're using. In our project window, create a new folder for your scripts and create a target script that you'll then apply to each of your different objects on your scene. Once you have the box collider, the rigid body, and your script applied, create a prefabs folder. Drag and drop all of your different objects into your prefabs folder, create original prefabs, and then you can see all of the different prefabs here with all of the components applied. So now it's your turn. So we have each of our different prefabs created, and we've applied our components to them. So now we're actually going to use our target script to control the force that they move in the air, the random position that they start off at the bottom of the scene, and then torque to be able to rotate the object. If you double click on your target script, now with our target script open, we're going to create some variables. So we're going to create a private variable for our rigid body so that we can just find it using getComponent. And we'll call this target RB, since each one of our different objects are the different targets we're trying to hit. In our start method, we're going to take target RB and we'll set it to be the component on our object, which is our rigid body. Now that we have our rigid body component, we need to apply a force on our object so that when it spawns, it moves up in our scene, so then it can fall down. So using our target rigid body, we're going to add a force. In this case, our force is going to be in the up direction. And we'll multiply this by a random value for now, so we're actually going to use our random range method. And we'll set it, just to test, we'll use 12 as the lowest value that it can be and 16 as the highest. And we actually want this force applied instantly, so we'll use a force mode. And we'll use our impulse. Another thing that we want to do is we actually want this object to rotate and move as it gets sent through our scene. So we're going to use our rigid body again. This time, we're actually going to use torque. So add torque. And so torque will actually apply the force for our objects to rotate. In this case, we just need the directions that the torque will be applied in. So we'll use random ranges for our X, our Y, and our Z. So we'll randomly generate a value that it will rotate in, say, -10 and 10. So that's on the X. We need to generate another random value. I'm just going to actually reuse this bit of code. So I'm actually just going to copy this. And I'll paste it into our Y value. And then I'll paste it into our Z value. So our X, our Y, and our Z are all calculating different random values between -10 and 10. Again, we want this force applied instantly, so we'll actually use another force mode. And then we want to set the position of our object randomly on our X. Finally, what we're going to do is we're going to create a random place for our different object to spawn. So we're going to get the position of our current object, and we'll set this to be a new vector3. And for the X, it'll be a random range. So I'll try and keep it between, let's say, like -4 and 4. So this way it stays between the left and right side of our screen. For our Y value, we'll set it to something like -6. That way it spawns underneath the scene. And then for our Z value, we can set it to 0. Now if we want to test and see how this looks, we can actually drag our prefabs into our hierarchy and we'll randomly create those effects. So it has the random position, it's got the random force applied. Now, one little bit of clarity that we can actually add. So since we're not actually using the Z value here, we can actually remove this. And since we're not really moving anything on the Z in general, in this case, it'll set the X to be a random range, the Y will be -6 underneath what our player can see, and our Z is always just going to be 0. So what you're going to do is in your target script, you're going to create a rigid body variable. You're going to get the reference for that rigid body component. Now that you have your rigid body component, add a force in the up direction using a random strength between 12 and 16, and make sure that you apply the force with an impulse. In our next line of code, we're going to add torque to apply rotation to our object, and we're just going to use randomly generated values for all of the different X, Y, and Z. And then we're going to set the position of our object to be a random range on our X, and just below what our player can see on the Y. Now it's your turn.
Okay, this one seems like a little more. Doesn't seem like that much when it's broken down into 4 steps, but a little more. So, let's take this a step at a time. Because we can do anything that we gotta do. So we want to declare up a new private rigid body. Rigid body. And we want to initialize it and start by making it a component, rigid body. And what was it after? It's just the parentheses, yeah. And then semicolon. Okay, so we got that. We're adding a lot to start. We're doing the add force. Oh. Oh. But this isn't spawning it. This is just adding the script to those objects. Okay, so we want target, add force up, blah blah blah, force mode, impulse. I mean, I guess I can just keep that up. That's what I'm putting on my script. Add force. Doing vector 3 up. Random dot range. In between. Impulse. Ah, man, this is using a lot of random ranges. And then it's just going to say, this will save you time, and then we'll do like the same exact thing, but it doesn't actually save you any time, it's the same thing. So... and then another random dot range. Transform position. Why does it always do that every time? I'm hitting enter. Okay. So, we did all that. The script is now been saved. So, those all appear to be working correctly. Okay, now replace messy code with new methods. But does it really clean it up? I feel like instead of the 3 lines of code you have, you're making like 20 extra lines of code. So does it really help? You gotta ask. Does that really help? Like, look at this. Yeah, I have to scroll down. That is all the stuff. All the stuff highlighted is what they want you to add. Compared to this. I don't even have to scroll. I feel like they, something's being misconstrued here. I'm just gonna do this on right now, because they don't add anything new. I already know how to make these methods. I know how to use the return. So, I can do that myself. So, we'll work on this right now. How many do I need? Max torque, X range, spawn pause. Make that 12. Forgot I can actually do this now. 12, 16, 10. 4 and negative 6. When do I want to set if they pass this point, destroy them. Would I want to set that? Or would I not want to set it? I feel like I want it. Anyways, then they want us to make new methods. Oh. Random force. Yeah. Up. There's the air. Okay. I don't really see the point of making it a method. It seems like it's just a waste of space, like you're actually wasting space. I guess for if you were showing this to someone else, it would help them. But it doesn't really matter. Making a random number. Forks. Okay. Leave it a comment. Leave a comment on the script if you understand it. Leave a comment on the torque. Let's see, what do we got now? We got return, random range, min, torque, max, torque. Oh wait, no, it's just max torque and then minus max torque. Pretty simple. And then another vector 3. Why don't we keep the vector 3s together? That just bothers me. Like if I was making this code, I would just change it purposely. So the vector 3 was with the other vector 3. Whoa, 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 whoa. Crash Bandicoot says. Return Ooh, new vector 3. Fancy. Random range. Minus. X range. Positive X range. Y spawn pause. Seems so pointless. Pokemon weren't meant to fight like this. Randomize the spawn position. Okay. Now we need to change the code. Instead of vector 3 up, you can just do random force. Then we got random torque, random torque, random torque. Force impulse and then random spawn pause. Okay. We did that one. Now we can create an object list in the game manager. Let's get to it.
We have all of our prefabs set up so they're randomly spawned at different positions. They have different forces applied to them so that they fly up the screen. Now we're going to use a list to keep track of all of these objects to spawn them. But instead of using a spawn manager, we're actually going to create a game manager, since we're also going to use the game manager to control the states of our game later. In your project hierarchy, if you click the create button and create an empty for creating an empty game object, we'll rename this game object as game manager. And then we need a game manager script to be able to actually use it. So in our scripts folder, if we right click, create a C# script and call it game manager, we'll now apply our game manager script to our game manager object, and you can see that it's applied. A cool thing you might notice is that on the script, instead of having the little C# icon on it, it actually has a gear icon. So in Unity, it actually tries to help you in a lot of ways, and in this case, because Game Manager is a script that people use very often, Unity actually creates a special icon just for it, so then that way you know that this is actually something that we'll use to control the different settings for our game. If we open up the Game Manager script, now we're going to do something similar in our Game Manager script to get the list of all of the objects we're going to use. So we're going to use public so we can apply the references. But instead of using an array, we can use a very similar data structure called a list. And then with a list, we actually need to give it the type of something. So we'll create a game object. and we'll call this targets. Now, a list is extremely similar to an array. So if we were to create our own array, we could call it game objects and then targets2. And you can see I misspelled game objects. So the notation is very similar, but with a list itself, we can actually pass it in the type of thing that we want, versus with an array, we have to tell the array what that thing is before we make the array itself. Lists and arrays have slightly different functionality in terms of the ways that they work. Overall, lists and arrays have slightly different functionality. So there are times where a list is more useful than an array. But for the purpose of this project, we'll just use a list for now so that we can kind of get used to it and see how it works and how similar it is. Now when we save, when we go into Unity, you can see our game manager script. It has the name of the targets. We can create a size, very similar to how we made a size for our array. So we'll set this to 4.
And if you're on a newer version of Unity, your size field might be over here on the right, and you might have little plus buttons to add items to the list manually. But otherwise, it's exactly the same.
Now we have 4 elements that we can give it. So we'll give it the bad object, the good object, the second one, and the third one. So what you're going to do is in your project hierarchy, you're going to create a new empty object, call it Game Manager. You're going to create a new script called Game Manager, apply that script to the Game Manager object. In your Game Manager script, create a new public list of game objects. And then in your Game Manager, just make sure that you apply the prefabs onto each of the different elements. We've created a Game Manager object that has our Game Manager script that now can control all of the different prefabs that we have. Now what we'll need to do is we want to instantiate them over time, so we'll use a coroutine again, and we'll learn about a new loop that we can use to do that. In our Game Manager script, we're actually going to create a new method first. Now we're going to create another IEnumerator method called spawnTarget. That way we can actually use the waitForSeconds method to control the length of time between each spawn. We need to use the yield keyword again. And we need to return a new waitForSeconds. And it needs a float of seconds. For now, we'll just use spawn rate because we'll create the variable later. Now we need to actually get a random object from our list to use, so we'll use our index so we can select that object in the list. Using its position, we'll get a random number between the first object and the last object. So similar to how in arrays we got the length, we can use targets, but in this case we actually get the count. And so this will actually give us the count of how many objects are in that list. In this case it's 4. So it'll be a random number between 0 and 4. And then we need to actually instantiate that object. So using our targets, we select the one at the index that we're going to use, so that way we either get our bad object or one of our 3 good objects. Now, the loop that we're going to use to control this is called a while loop. And a while loop is a fusion between a for loop and an if statement. So an if statement requires a condition to tell it when to stop. A for loop will iterate over something a certain number of times to execute your code. So a while loop will execute your code continuously, but instead of giving it a defined number of times to run, we can actually use a condition to tell it when it should actually stop running. We don't actually have a condition we're going to use just yet, so we'll just set this to be true. So while this is true, which will always be, we can do our line of code here to spawn our objects. Our spawn rate is still mad at us because it hasn't been initialized yet, so we'll create a private float spawn rate, and we'll set that to 1 for now, so it'll spawn every 1 second. Now, in our start method, we'll use a coroutine to actually start that spawn timer. So if we start coroutine, spawn target. Now, after we've saved, if we go to play our game, you should see through the magic of our programming that we have all of these different obstacles, and even though they're running into each other, that's totally fine. You can see it's randomly creating different obstacles over time. What you're going to do in your game manager class, make sure you create a spawn rate to keep track of the number of seconds that you want something to spawn. You're going to create another IEnumerator method for our spawn target. We're going to use a while loop, and for now our condition will just be that it's always true. In our while loop, we will yield return the wait for seconds using the spawn rate that we actually wanted to spawn at, so 1 every second. You're going to get the index of an object to choose from our list, and then you're actually going to instantiate that object using the index to grab it from our targets list. And then in our start method, just create a coroutine using start coroutine, and then call our spawn target method. Now it's your turn.
Okay, this one was a little more. Let me just, the only thing I didn't do was the start coroutine. So I have the wild, I have the wheel, I have the yield, and now I want to start coroutine. The coroutine is spawn. Coroutine is spawn target. Let me go over here. Then when we hit play, oh yeah, I forgot to hit my music for this one. I always forget to do that. But as we can see, it is constantly spawning objects. It is not destroying the objects. But it is spawning them. They're just all falling down over there. Okay. Well, we're definitely gonna need to fix that one. Destroy target with click and sensor. Getting tossed in the air, we need a way for the player to destroy them with a click. We also need to destroy any targets that fall below the screen. Yeah. That is what we need. So are we just going to have it collide with our mouse? Yeah. Huh. Interesting. Let's see how this works then.
Now our objects are all spawning using our game manager, and every second you'll see a different object being created. Now you can see over in our hierarchy that we have all of these different objects that are continually being produced and not being destroyed. So we'll need to destroy them in 2 different ways. So we'll actually get a register for when we actually click on one of these different objects to delete it. But then also we need to destroy it whenever it gets off of what the player can see. Now that we're in our target script, we're going to add in a new method. So in this case, we're going to override a method that Unity already has made for us, which is really handy. So if we private void, now we can type on mouse up, or we can type on mouse down. We'll also type in on mouse up just so you can see it. Now, because this actually happens so often in different games and in different projects, Unity has already made a method to detect whenever your mouse is inside of a collider of an object and you click down, or if you let go of your click, it will then fire off an event that will then immediately use whatever lines of code are inside of this block. So similarly, for when we did key presses, when you press the spacebar down or you let go of the spacebar, you could detect that and then you could fire off a line of code. In this case, we don't have to program any of that because we can just use these functions that already exist. So I'll get rid of on mouse up and I'll just use on mouse down for now. And so when the mouse is down inside one of our objects, we will then destroy that game object. Just to test our on mouse down, let's see if we play our game. You can see the boxes going up in the air. I clicked in the wrong place. One's gone, 2, 3, 4, 5. And now you can see we can delete them when we click on them. However, they're still getting created and they're not being removed when they actually leave the player's view. Helpfully, in our project, we actually already have an empty game object created called a sensor, and it has a box collider already applied to it that has a trigger. So in our target script, we can actually use the onTriggerEnter method, since the sensor is the only thing that has a trigger applied to it. And then when one of our objects enters the trigger for that sensor, then we can destroy it. One thing you might have noticed too when we were playing our game is that the boxes were spawning a little bit too low. So fortunately, since we saved the Y spawn position as a variable, if we just move up the boxes a little bit, maybe to like, let's call it a -2. Now you can see when we test our game, our boxes should spawn a little bit higher. And then when they run into the collider, they get removed when they enter the trigger. One thing you might notice in our target script is in our overridden variables, you'll see the private keyword. However, in our custom methods, you'll see that we don't use the private keyword. A really nice thing about scripts is, in fact, if we don't state that something is private or public, it'll automatically actually make our variables, if they're global, or our methods private. So what you're going to do is in your target script, you're going to create an on mouse down overridden method. And in that method, you're going to destroy the game object. So that way, when our mouse is inside the collider of one of our objects, when we click our mouse down, it'll actually destroy that game object. And similarly, you'll create an onTriggerEnter method where when one of the game objects runs into the sensor at the bottom of our scene, it'll destroy that game object too. Now it's your turn.
Okay, let's see what we got here. Now it should not only destroy game objects when I click them, it can also destroy them if they go past the screen. Well, that works out pretty well. I just not hit any for a second. Yep, they're being destroyed. That's always so neat. Okay, we did those basic things. Now we may continue. More or less stuff that we already knew about, but this is when we get into the UI. Objects fly into the scene and the player can click and destroy them, but nothing happens, and this also will display a score in the user interface that tracks and displays the player's points. Different point values. Cool explosions when each target is destroyed. Sure. I won't bother reading that part. But, let us leave.
We have the core mechanics of our game down, so when we press play, whenever we click on one of the objects, they disappear from the scene, and then if we let our objects fall off, they start getting removed from the scene because of our sensor. Now, to make this game even more interactive, we're actually going to create our first user interface to be able to actually get the score of our game. In order to do that, we're going to go to our project hierarchy. We're going to click on the Create button. We're going to go to the UI, and we're going to select Text Mesh Pro Text.
If you have a newer version of Unity, it might have these flipped and say Text Mesh Pro instead of Text Mesh Pro Text. But you basically want this Text Mesh Pro version instead of the default text because it gives you more control over the look of that text.
Now, the first time you do this, it might ask you to import the Text Mesh Pro Essentials. So just make sure that you do that by clicking on the Import TMP Essentials button. Now, Text Mesh Pro has been added to our project. Now, Text Mesh Pro is a really cool feature in Unity to be able to add different user interface or UI elements, adding text to our games. So it makes it very helpful and easy to manage. One of the things you might notice you can kind of see, it's very difficult to see. It's white text on a white background right now. In fact, Unity has, in our scene, added an entirely new element to our game. So you can see here, down in the lower left, that tiny little box is actually our game scene. And this massive rectangle here is actually where all of our different text and UI elements are going to be. In fact, if we actually drag this, and we'll make sure that we have our move tool selected, we can actually move this over to different parts of our screen. We'll just undo that for now. Now, all of our text and our UI elements are going to be rendered on this thing called a canvas. Now, this canvas is actually where all of our different elements are going to go. So if we add in buttons, or if we add in other text, it'll all be held on our canvas, which is the place where it manages all of our different UI elements. Now, with our Text Mesh Pro text underneath the canvas, we're actually going to rename this. So we'll rename it to Score Text. And you can see here that this has a pretty strange position on our scene, and we can move it around using our Move tool, or we can do other things with our canvas here to be able to place our text in certain locations to make it easier. Now, in fact, right now you can see that the positions are all set to 0, 0, 0. That's because in our inspector for our score text, there's this little box on the left-hand side for our anchors. Now, with the canvas, we can actually anchor our text in certain positions on the screen and base them off of those positions' values. It's particularly useful if you're doing something with different screen sizes. So, for example, somebody might play this game on a phone, which is a very small screen, and it could either be horizontal or vertical. So it'll have different space on the side of your game. Versus in our current game scene, we can see the sides of the box pretty easily. But if we always want to make sure that our text is always in the top left, we can anchor our text using this anchors box, and it'll have you select different options. So in fact, you can immediately select, for example, I want my text to always be anchored to the top left of our scene instead of in the middle. And now you can see that the X and the Y positions have actually changed. If I go back to what it was by default, it was 0, 0. That's because this is the center. If I do the top left, you can see that it changes the X to 621 and the Y to negative 250. If I move the text over to make it fit the scene, now you can see it pretty nicely. Just make sure we align that properly. So what will happen is if I ever resize my screen, our text will always try to go to that position where we've set it in our canvas. Now let's just make sure that it's positioned entirely correctly. For some reason my scale was set a little less. So if we set our text here in the top left, now because the anchor is set on the top left, you'll see that our text will always try and stay in that one position. So very helpful. So what you're going to do now is you're going to go into your hierarchy, right click, you're going to go down to Now we've added TextMesh Pro to our project and we've created our score text and repositioned it. Now other things that we can do with our TextMesh Pro elements is we have this UGUI section down here. And we can actually change the text. So what it will set it to be for now will just be score : and keep track of the score. Under main settings, you can see that we can change the font. So if you click on this little circle icon, it'll bring up different options that you can choose from. Kind of like this indie flower one, so we'll use that one. You can select different things like if you want it to be bold or if you want it to be italicized. I kind of just like it fine for now. You can even change the font size, so if I wanted to change it to something be even larger, 42, or if I want to make it smaller, 20, make it really tiny. I think 42 is a good size for now. And then if you want to, you can change the vertex color. So actually if you just click on the white box, you can actually change the color of your font too. So if you want it to be red, like bright red, or really dark black, if you're on a white background, whichever one. But I think white is totally fine for now, so we'll just leave it for white. So what you're going to do is you're going to go to the score text under TextMesh Pro UGUI. So in our project, we've set up TextMesh Pro and added a text element to our scene, so that way we can actually keep track of our score. Now what we're going to do is we actually need to use code and a variable to keep track of and update this score text whenever we need it. To do that, we're going to go into our game manager script. Now, one of the first things that we actually need to do in our script is we need to take advantage of these using keywords up here. Now, this entire time, as we've been doing our project, we've had these statements at the top of our program the entire time. Using is a special keyword in C# that enables you to import other libraries and packages into the current script that you're editing. It's particularly useful in cases where you import other libraries that you weren't initially using before. In our case, we've been using some of the standard C# libraries that we've needed, as well as we've actually been importing all of the different Unity methods and classes that we were using before. Different things like game objects or mono behavior. Since we're using TextMesh Pro, we actually need to import another package to do so. So we're going to type in using and then TM Pro. So now our project will be using all of the different classes and methods for TextMesh so that we can actually interact with them and control our user interface. At the top of our class, we're going to declare a new variable. So this will be public. So we can assign it in the inspector. It'll be a TextMesh Pro UGUI, and we'll call it the score text. So this will be the text that we created before. On top of that, we'll need an actual variable to store our score. So it'll be a private, it'll be a whole number, so we'll make it an integer, and then we'll call it score. In our start method, we'll make sure that we set score to 0 so that TextMesh Pro won't have any issues in using it. And then underneath that, we'll actually use our score text variable. And in this case, we actually have to use the text itself. So we actually have to use .text to be able to set the text. And we'll set it to be score as a string literal, colon, space. And then we're going to concatenate, in this case, our score variable. So as we update the score variable, it should change later. Now, in Unity, make sure that in your project hierarchy in the game manager, you assign the score text underneath the canvas into the score text in our game manager script. And now when we save, press play, you can see that our score is immediately set to 0. So what you're going to do is in your game manager script, at the top of the script, add a using TM Pro underneath all of the other using statements. For our variables in our script, we're going to create a public TextMesh Pro UGUI, as well as a private integer for our score. In our start method, we're going to set score to be 0, and for our score text variable, we're going to get the text element, and we're going to set that to be score colon, and then concatenate on our score variable. Now it's your turn. We've set up our game now so that our score text can actually use the score variable that we have in our game manager, but it doesn't actually do anything, so we're going to add in ways that we can actually update our score. In our game manager class, we're going to create another function so that we can actually update our score and then update our score text accordingly. If we create a new method, we'll make this void for now since it's just calculating our score and then updating something already. We don't need it to return any values. We'll call it update score. And then in our update score, we're just going to take out our score text where we update it here, cut it, and paste it into our update score. Now, every time we call update score, it's just going to tell us our current score, which isn't really that useful since our current score is 0 and it's not actually doing anything. So we're going to use parameters here so that we can actually add to our score every time, and then that way it'll update the score text here. So we'll use an integer and call it score to add. So this will be the score that we add into our current score every time. Now we need to actually update the score itself before we update the text, because that's what the text is using to actually change the score. So if we type score, and then we say plus equals the score to add, now it'll add whatever value we pass into our parameter onto our score, because remember, this is the same as saying score is set to score plus score to add. So the original score that we had plus the value that we pass in here. And now it should update score. So now if we go to our start method, we should say update score. And we're not adding anything because it's the first time it's running. So it should just tell us the score, which should just be 0 anyways. So if we play our game, you should just see a 0. Cool. So we know that works, but we still need to update it. So I think a good place to update our score in our game manager is probably whenever we spawn a target, at least just for now, just to see that it works. So in here, every time we spawn a new enemy, we'll update our score. We'll just say 5 every time. So every time one of those blocks spawns, it should just add 5 to our score. So if we test this in our game, cool. So every time one of these blocks spawns, it adds 5 to our score every single time. So works for now. So what you're going to do in your game manager class is you're going to create your own update score method and pass in a parameter for the score to add. And then you're actually going to use some calculations so that we can take our current score and add in the score. Now, we've set up our code so that we can update our score through a method, but the problem is that our score is just updating every time an object spawns, which could be fine for some games, but in this case, we want to actually update our score when we click on one of the boxes. So we're going to change that in our code. Now, in our game manager class, this could be one place where we actually create our code to be able to figure out which one of our targets we're spawning and then accordingly assign points as a result to update our score. Another way that we could do this is by communicating between our two scripts. In our target script, because we're already checking when we click on one of these objects and destroy them as a result, this could be a really good place where we can add in this line of code to be able to update our score. The problem is we can't just type in update score because our program has no idea what we're trying to do, because update score lives in our game manager script. What we're actually going to need to do is get a reference to our game manager script that's attached to the game manager already inside of our scene, so that way we can get the live data as it happens. To do that, we'll need to start by creating a reference to that game manager. So we need private, and then we can type game manager. So this will be our game manager script. And we'll just call it the game manager because that's what it is. Now in our start method, where we're assigning all of the different components, this is where we can assign our game manager to be the game manager script of our actual game. So we need to use game manager. We'll set this. Now we need to actually find the game object that is our game manager that we already have in our project. So we use game object, and we have to find, and in this case we're finding the actual name of our object. So it's game space manager. And then now that we've found the game manager object, we actually need to get the script from it. So we dot get component, and then we use our left and right carets, type game manager. So this will get us the game manager script. So now we have a reference to our game manager with our game manager variable. Now what we should be able to do in our on mouse down method is if we use game manager for a variable, and then we type dot, similar to how we have random dot range to call methods from other classes. In this case, we're calling a method from our game manager script. Should be, if we type update, send message upwards. Interesting. So I don't actually see, I don't see that method in there. If I go to my game manager script, let's see, update score. So the problem is, because update score is actually a private method right now, only other methods inside of our game manager script can see it. Similar to how we make our variables public to see them in Unity, if I make this method public and then I save our game manager, now in our target script, if I type in dot and I put update, there you go. So update score is now a public method. So now I can update this outside of the game manager script itself. So now whenever I click on one of the boxes, our score should be updated by 5. In Game Manager, I just want to make sure that I remove the update score from the spawn target because that's pretty useless. Save that script. And now, if I test my game in Unity, when I click one of the objects, my score updates by 5 every time. So, what you're going to do in your Great. So, now when we play our game, every time we click on one of the different objects that spawn, it updates our score by 5. Now, the one problem is we have these skulls, right? And they should be decreasing our points because they're bad objects. So, we're going to set that up in our code. In our target script, what we're going to do is we're actually going to create a new public variable. So this will be a public. Since we pass an int to our method, this will be an integer, and we'll call it point value. Now in Unity, if we actually go into each of our prefabs, you can see that on our target script, there's now a point value that we can apply. So with our skulls, we'll make them -10. With our first crate, we'll set this to be 5. In our second crate, we'll set this to be 10. And then in our third crate, we'll set this to be 15. So now each of our prefabs has a point value assigned to it. Now back in our target script, we can change the 5 in our update score to be the point value. And now when we test our game, because each of these different scripts on all of the different prefabs are all unique in their own way applied onto each of these different objects. Now, if we play our game and we press play, we should see different point values. -10, -5, that one goes up. That one is 5, I think this is 15, perfect. So we have our score updating every time we press one of these different boxes. Broke 100. Perfect. Okay. Now, the cool thing is, because of our target script, each of the point values is assigned uniquely onto each prefab, so they each have their own value. We could do this a different way, where in our on mouse down, we could check by name which object we're actually assigned to right now. So for example, if it's that first crate, then we can update the score using an if statement. However, that's a bit more work and a lot more coding, which is something if you want to do, you can. Otherwise, you can use this method where we make the point value public, and then you can assign it differently onto each different prefab. So what you're going to do is you're going to create a new public int for your point value. Our score is now perfect and ready to go. So each time we click one of the different objects that spawn, it gives us a different number, which is a lot of fun. You can see the score updates, but it definitely doesn't look or feel that cool when you click on the different ones. So we're going to up the coolness factor by a lot by using some particle effects. In our target script, we're going to create a new public variable so we can assign it in our editor. It'll be a particle system. And we'll call this the explosion particle. Now we want to make sure whenever we destroy one of our objects, we use our explosion particle. So in our on mouse down method, we're going to create a new explosion every time we destroy the game object. So we can actually instantiate our explosion particle. We'll set the position to be the position that our current game object is at. And we'll just set the particle to be at the same rotation that it was at before. Now, in Unity, just make sure that on each of the different prefabs, you open them up, and we need to assign them each explosion particles. So if we open up our course library, we actually have some particle effects that we can already use. So I think for the case of our skull, we'll make it like, let's see, we'll make it like a green color. See what that looks like. For our first good crate, we'll make this something like yellow. For our second good crate, we'll make this something like a purple. And then for our third good crate, we'll make this something like, let's make it blue. Now, if we try our game again, if we click on one box, there's purple, yellow. This one should be green. Cool. So now we have these really cool eye-catching effects whenever we click on one of the different objects, and just makes our game feel a little bit cooler. So what you're going to do is in your target script, you're going to create your own public particle system variable. In your on mouse down method, where we destroy our object, we are then going to create a new explosion particle, and we'll make sure to set it to the current position of what our game object is at, and make sure the rotation is the same as the actual explosion particle. And then in Unity, just make sure you go to each of your different prefabs and assign an explosion particle from the course library folder in our particles folder, where there are a variety of different explosions that you can use. Now it's your turn.
Well, that was all it was for this one now. Hang on just a sec. Finishing off the particle effect thing. I'll make this one yellow. And now let's see. Yeah, then I gotta. No. You're not gonna trick me. Get those yellows. Good stuff. Ooh, double skull knockout. And that went over the wall. Shouldn't the wall have a collider then? I guess it's not a big deal. Well, that's done then. Learned all that stuff. Isn't learning fun? No. Stop spawning and score on game over. Add restart button. Make restart button work. Show restart button on game over. So we'll be able to actually make a real clicker. Click.
Now we have it so that whenever we play our game and we click on any of the different objects, you see we gain score. But eventually what I want to happen is whenever we miss clicking one of these objects or we go to say a negative score, we actually get a game over. So we're going to set that up really quick. In our canvas, if you right click on it, go to UI and create a Text Mesh Pro text again. We'll rename this the Game Over text. And now that it's renamed, let's change the text in the actual box. Under our text box, now it says game over, cool. Now let's make it a similar font to what we had before. Now it's really hard to see, so I'm going to actually make the font larger. So now you can see it's a bit bigger. If I even bold it a little bit, has some thicker lines. And it's really hard to see against this white background, so I'm going to change this to be like a dark red. There you go. And you can see that it has this weird issue where the text is kind of filling outside of the box. So one thing that we could do is we could actually change the width and height of this rect transform so that it actually covers this entire text. But instead, I'm actually just going to use my different settings for the text itself. So if we scroll down through the UGUI component, you see there's all of these different options. So we can actually set it so that way it's center aligned. So this is nice, that way our text will always be within the center of our text box. And then what we can do is, you can see here wrapping says enabled. So if we actually disable wrapping, this means that our text will no longer be wrapped within just that text box itself. So there you can see we have our game over right in the center of our screen. And then what I'm going to do is I'm just going to move this up a little bit just by clicking and dragging on the position Y. There you go, so it's a little bit higher in the screen. Now one thing that I could do is I could change the anchor point, but in this case, since I want our game over to be centered in the middle of our screen, I'm going to leave the anchor point as the center point. So what you're going to do is you're going to create a new Text Mesh Pro text. You're going to rename that text to be game. Now we have our game over text for our player, and we actually need to be able to turn it off and on. So what we'll do is on our game over text element in our hierarchy, if we disable the game object by clicking on the checkbox in our inspector next to the game over text field, you can see that now our text has disappeared from the scene, which is good. That's exactly what we wanted. And now we'll write some code so that we can turn this back on. Now, in our game manager script, we'll add another reference to our game over text, similar to what we did with our score text. So we'll make it public so we can assign that reference. It'll be a text mesh pro UGUI, and we'll call it game over text. And then in start, we're just going to test and see. So if we use game over text, and then we use the actual game object, we'll set that game object back to active. Now make sure that you use Boolean, so we use true so that we can set our game object back to active since we disabled it. And then as a quick test, we're going to play our game. And we should have seen the text pop up right here. Let's see. So I didn't actually set the reference to our game over text in our game manager, so I should do that first. So now let's just save, make sure, press play, and then game over should pop up right there. Perfect. Cool. So what you're going to do is you're going to go to your game over text in your hierarchy, uncheck the checkbox on the top right at the top of your inspector, so that way we disable the game. When we play our game, you can see that the game over text just pops up, which is definitely no good because we've immediately lost the game. So we're going to set it so it only pops up when one of our good objects hits our sensor at the bottom. So in our game manager script, we're going to create a method to be able to call setActive whenever we need it to. So underneath where we update the score, so we'll create another public method because we'll actually need to use this outside of this class. Make it a void so it doesn't return anything. And it'll just be game over. We don't need to pass it any values, so it'll just set the game to be over when we need it to. And now that text we have in the start, this line of code, we can cut this with Control or Command X. In game over, we'll just paste that back with Control or Command V. And then let's just clean up this empty space here so our code is a little bit more readable. Perfect. So now we can call game over whenever we use the game manager, so that way it can pop up the game over text. In fact, we already have a place where we use the game manager. In our target script, we actually had the game manager already set up to be able to update the score when we needed to. So what we're going to do is we're actually going to find the bit of code where we collide with our sensor bar at the bottom of the scene. And this is actually where we'll call the game over. And we'll just use that game manager variable that we had before. And we can just call game over now because it's a public method. So now when we test our game, whenever one of our objects here runs into the sensor at the bottom, and we'll just let it go so that way it hits the sensor, now we have a game over, which is good, but in this case we only want our game over to pop up whenever one of these good items hits the bottom of the scene. In fact, if we select our sensor here, and then we zoom in on it using our focus, our F key, while our mouse is in the scene. Zoom back in so we can see the actual game. So we want to be able to know when one of the objects that runs into it is one that we want to trigger a game over. So what we'll do is we'll actually go into our bad prefab. And then in our prefab, we're going to add a tag in our inspector on the right side. Click on untagged, we'll add a tag. Since there's not currently any in there, we'll click the plus button. We'll call this one just bad, so it'll be a tag for any bad items. Save. Now make sure you select the prefab again, and then just select tag and change the tag to be bad. So now we have a way of knowing if we run into a bad object. So if we leave the prefab preview, so now that we have our bad tag, we can actually see which objects we want to collide with the trigger to be able to make the game over happen. So we'll use an if statement so that we can actually see when that happens. And we're going to use a condition where if the game object who has a tag, and that's called bad, then we want the game over to happen. So in this case, if the game object that falls to the bottom, if our skull hits the sensor, then it will trigger our game over. But we don't actually want that to happen. What we want is whenever any of the good objects run into that sensor. So actually, if we just put a not or a exclamation point, so it will negate the statement. So if the game object that runs into the sensor is not bad, so if it's one of our good ones, then it should use the game over method. So let's see if that works. So if we test it really quick, let's click on some of these boxes. And then if we let the skull actually go, so the skull still triggered our game over. You know why that happened? Because I forgot to save my script. Always make sure you save. So now that we save, now if we test our game, press play. So let's get some of the boxes out of the way first, just to make sure that one of the skulls falls down. So no game over, and now there's a game over when one of those black boxes hit the sensor. Perfect. So what you're going to do is in your game manager script, you're going to create another public method for game over. And then we're actually just going to take that line of code that we had in start to set our game over object to active when we call this method. Now, in our target script, we're going to go down to our onTriggerEnter method, and we're going to add in some more lines of code. So if exclamation point for the negation operator, game object is a bad object, so if the game object is not, because of the negation, a bad object, then we start the game over screen. And then in Unity, just
Oh yeah, no. The voice moves if I don't mute myself. Well, the model moves its mouth if I even if I don't have my mic on my OBS, because different programs. I guess I could mute the mic on my my model renderer if I wanted to. It's I'm just watching the video that's below the Unity manager there. The video for the classes and all that junk. Forgot to turn this back on. Oh, did I do something wrong here? Is that what I wanted to do? Let me see. Now all my boxes are flying up. If I hit that, it doesn't happen. But now, if the skull collides with anything else, it triggers a game over. So this skull's collided with something else, so it gave me a game over. Well, the game over thing works in general, and that's what they want you to do. So, I guess it works. I suppose it works. That's what they wanted you to do. We tagged it as bad. Stop spawning and game over. Wait. That's what we're doing? I'm dumb. Let me look at this really quick. We hit the good game objects. Everything is fine. It should only trigger a game over when we don't click on the good stuff. So, okay, yeah. Never mind, that makes more sense now. When we miss clicking it, it gives the game over. That's what it was saying. I'm dummy. Dummy thick.
so we have our game set up. So whenever one of the boxes falls to our sensor, the game is over. And game over. Cool. But we do have this problem still where we can, in fact, still spawn objects, and we can actually keep gaining and losing score, which is definitely not something we want to happen. Kind of defeats the point of high scores if you can keep gaining the score after your game is over. So we're going to fix that. So we're actually going to go into our game manager class, and we'll create another public variable so we can actually use this outside of this class. We'll make it a Boolean so that we can set it to be true or false, and we'll call it isGameActive. And so this Boolean will tell us when the game is or is not active. Now we need to set this Boolean, so we'll set this in our start method. So isGameActive is true. And now that we know when the game is started, our game is active. On the other side, we should also see when the game is over, the game is no longer active. Now, the first problem that we have, now that we know the state of when our game is playing or not playing, is we keep spawning enemies, and in fact, we have the spawn target method here. Now, we put this while loop in here to have a condition for when it's true, it'll run this bit of code. However, we just made a variable to see when the game is actually running, so in fact, we can remove this true and just use isGameActive. So now, when the game is active, it'll run this line of code, and then when the game is over, it'll stop. So make sure we save that. Now, in our target script, we want to actually stop getting points whenever the game is over, so we should also check for that as well. So in onMouseDown, if we add another if statement, and we check whenever the game manager tells us that the game is active, so since we used a public variable, We can now use that and check whenever the game is active. Then we'll do the line of code to be able to get points and destroy objects. And then when the game is over, it won't run this code anymore. So if we save our game, and then if we just do a quick test in Unity, we should see our objects spawning. We should see our objects spawning. I don't see any objects spawning here. Okay. I think we broke something. Let's see. So we spawn our objects in our game manager, and we use our spawn target. So game is active. Well, the game is active. So I think what the problem is, so because we set game active after we start this coroutine, the coroutine actually never knows that game is ever set to active, and so then it actually just breaks entirely. So in fact, I think if we just cut is game active and we paste it above the coroutine, so now when our game starts, it'll actually set the game to true, and then it goes into the coroutine, and then it'll start spawning enemies afterwards. Let's see, let's check that real quick. Save. So let's see, if we did everything right, hopefully we didn't break our game again. There you go, cool, okay. Nice, so now we have the object spawn again. So let's just see really quick. So object falls, object stops spawning, couldn't click on any of the objects. Okay. So as you can see, in this case, the order of our code matters a lot. Because what happens with start coroutine is it creates another thread or another loop where it then starts creating all of these enemies on its own outside of our actual game updating. And so because the game is never actually ever set to active according to this coroutine, then it actually just doesn't even spawn any enemies. So always make sure, especially, to update your variables and set them before you ever have to use them. That way you don't run into a problem like that, and then you can't figure out why you can't solve it. So if we wanted to, we could take our score, cut it, and then we also set it when we set our game active, and then there you go. So now all of our variables are being initialized before we actually use them. So what you're going to do is you're going to create your own isGameActive Boolean variable. Make sure it's public. In your start method, make sure you set the is. We have our game over working perfectly now that we fixed that bug. So we can have one of our objects go to the bottom, game over, object stops spawning. I can't click this box. Very frustrating. Now, we have no way of replaying this game now that it's over, so I guess the game just ends. Well, that's not a good thing to do. So we'll actually add a way that we can restart our game. So we're actually going to create a button, our very first button, and we're going to do that on our canvas. So if we right-click on our canvas, go to UI, and select the button option.
And if you wanted to, you could actually use this Text Mesh Pro button to get more control of how your text looks.
This will now create a button for us, and you can see the button on the center of our screen. We'll actually need to zoom out of our scene view. And let's see if we can, there you go. Let's get that canvas back. Cool, so you can see our button here. It's just exactly in the middle of our scene. Now, I'm just going to position this really quick, so I'm actually going to turn back on the game over text, and our button will just put a little lower on the Y position, somewhere like there. Looks good. Now we're going to hide our game over text once again. So we can't see it, but we can see our button. Now, in our button, we're going to rename it, so we're going to expand it, which is actually where the text is stored under. In our inspector on the right, you can see we have this text script component. So this is where we can change the text of our button. So we'll change it to restart, and you can see it's changed down here. And we can do the same thing. We can select the radio button, this little circle on the right side of our inspector. And it gives us options of different kinds of fonts we can select. You can see it changes down at the bottom. Oh, there you go. This is the same one that we were using before, I think. So We'll use that one, the indie flower in my case. Let's see, we can make the font size a bit bigger. Let's see, it gets a little too large there. So mine's set to about 15. I'll make this bold so it's a little bit more visible. Restart. So now we have our button set up and ready to go. And then we need to do one more thing. So we have our restart button set up. And I'm going to rename this to the restart button so that it's easier to see as soon as I try and find it. So what you're going to do is you're going to right click on your canvas. You're going to create a UI element. We're going to make a button. Make sure you rename your button to be the restart button so we know where to find it. You can change its position on the Y so that way it's a little bit lower than the game over text that would pop up. If you expand the restart button, you'll actually see the text element underneath it. And then in the text component, you're going to change the text from button to restart. And then you're going to change the font to whatever font you want it to be. You can change the fonts. Now, we have our button set up in our game, but we actually need to use this button to tell our game to restart when we click on it. Now, in our game manager is actually where we're going to tell our game to restart our game. Now, the way we're going to do that is actually through managing our scenes. So, we actually need to use another library, very similar to how we used our TextMesh Pro library to be able to interact with TextMesh Pro elements. So in this case, we're using Unity Engine because our scene management is under the Unity Engine library. And we're actually going to grab specifically the scene management library itself. And so this will actually enable us to interact with and manage our scenes in our scene folder. Now, we're going to go to the bottom of our game manager script and we'll create this method underneath game over. So we'll call it public so we can use it outside of the class void restart game. And then this is actually where we're going to reload our scene. So we can actually use the scene manager class and we'll load a scene. And in this case, we could use the name of the scene, which I think was prototype 5, or we can use code to just tell us and make our lives a little bit easier. So scene manager dot get active scene. So this is the scene that is currently active for the player. And then we actually need to get the actual name of that scene. So this handy little method over here, this line of code, using our scene manager that we just imported from the scene management library, it enabled us to load a scene. In this case, we're just reloading the scene that we're currently using. So we got the name of our current active scene, and our scene manager actually knows which one is the current scene. So we make sure we save this. So our buttons work very similarly to how buttons would work on your phone or on a website where you can click on them in Unity and they'll do something. Fortunately, buttons are already configured to do that. So they actually use this onClick method, which is very similar to how on our different prefabs, whenever we do the on mouse down, we can destroy the objects. So specifically, our restart button knows when we've actually clicked it itself. You can see there that it has a list, and we can actually add to this list. So what we're going to add into our onClick is we're actually going to take our game manager in our hierarchy, click and drag it into this little box here. And now you can see here on the right side, there's this no function box, this drop down. So if we click on that, this will actually give us all of the different functions that we can use in all the different variables. So you can see like transform, you can see game manager, and in game manager, look, there's restart game. So now, if we save, now that restart game has been added to the restart button on click. So the game will end when that box hits, game over, and then we restart. And there you go. And then the game's over again. So now we have a way of restarting our game. We can just restart whenever we want if we really wanted to. So now, what you're going to do is in your game manager script, you're going to add this line of code using Unity Engine Scene Management. So that way we can actually manage our scenes and load them in. Once you've added that library, you can go and add a new method. Make sure it's public so we can use it outside of this class. It'll be void, and it'll be called restart game because it'll be restarting our game. We're going to get the scene manager class. Now that we've used the scene management library, that class will actually let us use the load scene method, which in this case will be taking in a string, the name of the scene that we want to load. And in our case, we're going to reload the current scene we're using. So our scene manager knows which scene is currently the active scene, and then we can actually grab the name of that scene, which will give us the string. And then finally, on your restart button, in your hierarchy, if you scroll down in the inspector, you'll see that there's an on-click list here. And if you press the plus button, you can add a new event to happen when the button is clicked. There will be an empty box here where you can actually click and drag the game manager into that box, and then it will actually populate over on the right of onClick where it says no function. If you click the drop down, there will be a whole bunch of different methods and variables that you can actually use. And in our case, since we have the restart game method, we'll use that to be able to restart the game when this button's clicked. Now it's your turn. We can control the state of our game now, so we can restart the game whenever we want, which really is not actually exactly what we want, but especially whenever the game is over now, we can restart the game, so that's helpful. Now, we don't want this button in our face the entire time, so we're going to turn it off similarly to how we turn off our game over. In our game manager script, we'll actually need another using statement. So this time we're using Unity Engine .ui. So this library will actually let us interact with our button specifically. In our variables, we're going to declare a new variable. This one will be public so we can get a reference to our button that's on our scene. That's called restart button. Now, because I know I'm going to do this later, it's just easier to just do this while I'm here. So similarly to how in our game over, we set our game over text to active, we can do the same thing with our button, in fact. So in restart game, now we can do restart button dot game object, and we'll set this one to active. Make sure you use that Boolean variable. And then in Unity, we need to do two things before we test. So our game manager, we drag our restart button onto the restart button field. I've remembered this time. And then we want to just turn our restart button off, disable it by clicking on it, going to the inspector, clicking on that little checkbox so it disappears. Now, if we test our game out, when our game is over, we should magically see our text and our button reappear on the scene. So our game is over, and there's no button. What did we do wrong? In fact, what I really wanted to do was set our button active when the game is over, because we can't restart the game if there's no button. So what we're going to do is we're going to cut out the restart button, and we'll add it to the game over. And then now we save this. So now when the game is over, now both our button and our text should show up. So if we test one more time, we have all of our different objects that'll pop up, all of the little boxes and skulls. The game is over. Now we have the restart button. And then when we press restart, boom, magically, the words and the button disappear from the screen. And there they are again. So now we have a way of ending our game and restarting whenever the game is over. So, what you're going to do is in your game manager script, make sure you add this using statement for unityengine.ui so that we can actually interact with the buttons. In our variables, we're going to create a new variable for our restart button, and it'll be of type button. Make sure you make it public so we can interact with it in the editor. In your game over method and not your restart game method, you can get the restart button, get that game object, and set it active. And then just make sure that your restart button is disabled in the inspector. And in your game manager, you connect that reference of the button in the scene to the button variable that you created. Now it's your turn.
Huh. Well, that's neat. Feel like I learned a lot from that one. Very interesting. What's the difficulty? No one cares. We don't need the difficulty. Difficulty is for babies. It's for babies. It's for actual babies. Like, are you a little teeny baby? Little teeny tiny baby? Teeny tiny baby man? This is the last thing we have, though. And then it is the challenge, then the lab, and then the quiz. The lab I always skip over, because that's supposed to be for the personal projects thing, and we'll worry about that when we get to it. And then we'll just have introduction to user feedback and testing. Projects. The next steps. Then career and research preparation and introduction to portfolios. What would my portfolio be? Here's an example of my code. Is that Solid Snake? Licking? Liquids? Yes. Yes, it is. You're hired. What would it be? What would it be? Create the title, text, and menu buttons. Create all the elements we're going to need, including a big title, as well as 3 different buttons. Okay. Duplicate your game over text, create your title text, adding its name, text, and all of its attributes. Duplicate your restart button, and then its attributes, create an easy button. And duplicate the new easy button to create a medium button and a hard button. I guess I'll just do that now. I don't think that's anything I need to get overly complicated over. Duplicate your restart button, turn it to easy button. Easy. Did I spell medium right? Yeah. Yeah. Hard. And we'll duplicate this. And we'll rename it Wacky Click. Wacky Clicker. It's a wacky clicker. That way I should name it something else. Title text. Title T. Wacky clicker. It's Wacky clicker. Haven't you ever heard of Wacky clicker? Oh geez, Wacky clicker? Oh boy, Wacky clicker sure does look wacky, doesn't it? I bet you're thinking, wow, that is one wacky little clicker. We'll even italicize it, make it real wacky. Underline. Yeah, check through. Wacky clicker. That's even wackier. See, it's very wacky. Okay, you can go up. Okay, and they want to start at these. Title T. Make a nice blood red. Can have nice green. Medium. Maybe you can have like a weird green. Okay. Title T. Where's the title? Okay, we made all of the little buttons. Add difficulty button script. Create a new difficulty button script. Okay.
Now we've added all of our buttons and our title text to our game, but these buttons don't actually do anything, so we'll need to create a script to do so. One thing that we're going to do is just some cleanup. So in fact, because we copied that restart button and duplicated it, if you go to the on click, if you select one of the buttons in the inspector and scroll down, you can actually see that it's still tied to the restart game, and we don't want these buttons to just be restarting the game all the time. So actually, in on-click, you can see the little minus button, and if you just click that, it'll remove that game manager. So you go through each of the different buttons, remove those, so now we can't just magically restart our game. Definitely don't want that to happen. Now what we're going to do is we're actually going to make a new script now. So in our scripts folder, we right-click, create a C# script. And this script will be called difficulty button, to control the difficulty when we use our buttons. So we have that. Now what we're going to do is we're going to actually select all of our different buttons, our easy, our medium, and our hard button. And we're going to scroll all the way down. Now I'm going to add a component. And we're going to actually search for that difficulty button script. There you go. Now the difficulty button has been added, and we can actually check each one. 1, 2, 3 scripts. Perfect. Now in our difficulty button script, in order to interact with those buttons again, we need to make sure that we use that library that we had before. Very handy. So Unity Engine.UI, because the UI library helps us interact with buttons. So now we need to get references to our buttons. So we'll make it private, and we'll just call it button, and we'll name it button because we're getting this button. And then in our start method, we're just going to make sure that we get the actual button component on our button. So we use our button variable, and we get the component, and we're looking for the component called a button. And then make sure you add parentheses. So now we've attached these scripts onto each of our different buttons, and we're making sure that we get that button component from our button so we can get a reference to it in our difficulty script. So what you're going to do is in each of your buttons, make sure that you go to the on-click section underneath the button component. Remove the reference to the game manager on each of your different buttons. You're then going to create a difficulty button script, and then make sure that you attach it to each of your easy, medium, and hard buttons. And then in your difficulty button script, you're going to make sure that you use the Unity Engine UI so we can use buttons. We're going to make a private variable for our button component on our button. And then in our start method, we're going to make sure that we get the variable of our button and set it to the button component currently on our button. Now it's your turn.
Alright, I forgot one thing. I don't know why. Oh, it's outside of it, that's why. I was wondering why that script wasn't working. So that's all fine, but I did not change scene here. The Y goes off. Why? Why do you go off? Why? It'll be a very small easy button. Score is always active. Okay, set difficulty on button click. Now that we have a script for our buttons, we can create a set difficulty method and tie that method to the click of those buttons. Okay. So create a new void set difficulty function inside debug log was clicked. I didn't spell that right, did I? If equal D. Oh, cool, I did spell it right. Never mind. I'm a genius. I'm a lyrical genius. I'm a god. Debug.log. Our favorite little method. Parameter thing. What's clicked? Okay. Then on, it's on start, right? Yeah. On start. One click. Set difficulty. Okay, let's see if that functions at all. We got all that set. Easy was clicked. Okay, well, those work. Those function. What is your prime directive? To beat your butt. Make button start your game. Game manager, create a new public void, start game function, move everything from start into it. And difficulty button. Create a new private game manager, initialize in start in the set difficulty function. Call game manager start game. Okay, well, I'll listen to this one. I feel like this one I could probably do too, but we'll give it a listen.
Our title screen is now looking amazing, but we do have this problem where we're not actually starting the game. The game has already started, and we can actually click all of these boxes, but in fact we can also click these buttons, which is helpful. And down in the bottom you can see we know which button was clicked. In fact, if I squeeze between this button, I can restart the game, so that's fun. So we'll actually need to fix that and actually start our game. Now, in our game manager script, since this is the script that's managing all of the different states that our game is going through, like restarting and game over, we'll add a start game method into this so we don't have to keep immediately starting the game on start. So we'll add a new method. We'll make it public so we can use it outside of this class. It'll be void and it'll be called start game. Luckily, we've already written code to start our game, so we're just gonna use that. In our start method here, you can see that we have our different settings. So we'll take all of these and we'll cut them out of our start method, and we'll paste all of that code into our start game. So now, when the game is started, we know that the game is set to active.
Welcome to
The
Glimmer!
score is reset, and then we can start spawning all of our enemies. Make sure we save, and then
Oh, yeah, I had myself muted still. That scared me. I should probably turn that down at some point. Anyway, paying attention to this more.
in our difficulty button script, we're actually going to need a reference to the game manager, just like we did in our target script. So this will be private, and we just need to get our game manager, and we'll call it the game manager because that's what it is. Now, in our start method, we also need to get a reference to that game manager. So we'll get our game manager variable, and we'll set it or assign it to the game manager game object. So if we use game object, in our hierarchy, we will find the object that's called game manager. And then once we've found that object, we'll need to get its component, which is handily also called the game manager. And then in our set difficulty method, we can now use our game manager. and we can use the start game method that we wrote before. So if we test our game now, nothing should happen when we press play. None of those crates are spawning. But then if we press one of our buttons, let's go for easy mode. There you go, we got some crates spawning, and then our game should go over, get the game over. Cool. So we're almost there, but at least now we can start the game when we press one of the buttons. So what you're gonna do.
Oh, okay. That's all you need. Right. Now I have to do it. Okay. I moved that stuff over to start game. Making that its own thing. And then we want to go on difficulty button and grab that. Oh yeah, they want us to set that too. Save that. Then we go over here. Okay. Oh yeah, I should define this first. No caps lock. Please. Please do not caps lock. We want big game manager, then we want little game manager. Doesn't do it right. Ever. And we gotta set it. Game manager equals game object. Find game manager again. And we're getting component of the game manager. The game manager for the game manager in the game manager. How many game managers are there? That one, semicolon, that's good. And set difficulty, we just want to throw that up in here. Game manager, start game. Okay. So then all the buttons will start it if you press them, but they don't have any difficulty settings for it. Then we're going to need to change that next. Buttons start the game. We need to deactivate the buttons. This one seems pretty simple. Right-click on the canvas and create an empty object, rename it title screen, and drag the 3 buttons and title onto it. Okay, I can do that. Title screen. Dump those in there. Okay. Game manager, create a new public game object, title screen, and assign it in the inspector. Game object, and then just always like to check I spell their way right for their tutorial. Okay, and then title screen, game objects at active false. Under start game. No, not send message. Set active. False. So then they would turn off. Okay, that makes sense. And we just need to define those in Unity. And we can do that under here. Oh yeah, that makes sense, setting them all up. Yeah, huh. I didn't really think about that, but that makes sense. Now that is in there. That is in there. It's good. It's cool. It's sweet. It's gnarly. But yeah, and then when we hit our play, got a nice little title screen where the sun will suddenly dissipate if you restart the game. But then we just click on hard, even though that it won't actually change it to a hard mode. We don't have a difficulty right now. I'll hit every skull, get our score as low as possible. But score goes up. We don't hit the box, we'll get the game over. Then we can hit restart to get our new display. I don't know why it changes the color. I'm not sure why it's doing that. I mean, it still functions how it's supposed to. The lighting just changes for some reason. I'm not really sure why. No clue why it does that. Maybe it was because of how I changed the colors or something. I did something wrong there, maybe. Use a parameter to change the difficulty. So we're just going to change, like, the number of how things spawn or something, right? That's what it seems like we're going to do. But we'll give it a listen.
So our game is just about there. We have our title screen. We can click on one of the buttons. We have all of these objects that spawn. We lose the game. We can restart, reload our scene. We get our title screen again. The last thing we need to do is actually make these difficulty buttons work, so then our players can have a little bit of fun. In our code, in our difficulty button script, we're going to create a public variable so we can assign them in Unity. This will be an integer, since we're just looking for whole numbers, and we'll call it difficulty. Now, in Unity, if we go to each of our buttons and we scroll down, you can see that the difficulty variable can be set. So for easy, we'll make the difficulty 1. For medium, we'll set the difficulty to 2. And for hard, we'll set the difficulty to 3. Now, because each of these different buttons all control their own variables, it'll be really easy to use them. In our game manager script, we should go down to start game, since that's what the difficulty buttons are using, and we'll actually pass in an int difficulty parameter so that it will use this integer. And then, lucky for us, because we actually made a spawn rate before, we can actually now use that variable that we thought of before to control our difficulty. So if we set our spawn rate And in this case, we want our spawns to happen faster, so we'll divide spawn rate by the difficulty that's passed in from our buttons. So, when we pass in our difficulty from our buttons, for example, our easy button, our spawn rate here, which is currently set to 1 second, will be divided by our easy difficulty, which is 1. So 1 divided by 1 means our spawn rate will stay at 1. If we pass in our medium button, then our difficulty becomes 2. So it'll be 1 divided by 2, which is half, or 0.5 seconds. And if we use our hard difficulty, it'll be divided by 3. So 1 divided by 3 is 1/3, or 0.33 seconds. If you remember, there's one little bit of cleaner code that we can write. So this is pretty redundant right here. In fact, we can use the same style of operator that we used for adding and multiplying values that we were trying to multiply themselves against other things. So if we do spawn rate / equals difficulty, this means spawn rate is set to spawn rate divided by our difficulty. Make sure we save that. And now, in our difficulty button script, start game is a little annoyed with us, so we'll pass in our difficulty variable. So whenever one of the different buttons is pressed, it'll send in that difficulty to start game, send that information to our game manager, which will then use that updated spawn rate to spawn enemies faster or slower. So now we're really communicating between the different scripts that we've written, very similar to how we were learning how to use methods and parameters before. If I save this, and now in Unity, when I go to my game, in this case, I will select the Maximize on Play button on my game window. So when I press play, our game goes full screen. If I press one of the buttons, so easy, we should see a fairly slow spawn rate. If I restart, I press medium, it should be a little bit faster. That's very fast. That's a lot of skulls. And then if I restart one last time, hard mode should spawn a lot of boxes very fast. I can't even click on all of them. So, what you're going to do in your difficulty button script, add a public variable that's an integer for your difficulty. In Unity, select each of your buttons, and now that you have that difficulty variable, you can set each one to be 1, 2, 3, however difficult you want it to be. In our game manager script, if you go to your start game, pass a parameter into it using int difficulty, add a parameter. With our spawn rate variable, we're going to divide that by the difficulty, so that way our objects spawn faster. And then finally in difficulty button, under set difficulty, make sure you pass the difficulty variable into your start game method. And then test your game one final time using the Maximize on Play button in your game window. So when you press play, your game goes full screen. Now it's your turn.
I did something wrong. It's not spawning objects now. Okay, let me look at this. I might have just written something the wrong way. I do that sometimes. So in public, for difficulty button, first, did I spell difficulty right? diffficult. diffficult. Why? Game manager is baby. Start game baby. Void set difficulty. No, that is supposed to be big. I don't know why it says that. Okay, so then we want to go down to start game. Start game we want in int difficulty. And the spawn rate. Then in difficulty parameter. Start game function. And start game set spawn rate equal. Oh wait, did I write the divide sign the wrong way? No, that's correct. Fix the error in the difficulty button by pressing parameter. So by all means, it should function. Unless I did something else wrong. Oh, why did these change? That's what's wrong. The difficulties went back to a different variable. They should not be. Oh, I think it was because the public I made, I wrote the wrong way. Before, I didn't lowercase it when I was supposed to. So it did the wrong thing. I think it was just because of that. Possibly. We'll see. Okay, well things are spawning now. I like how if things hit each other, you kinda can't win. But let's let us die really quick. So we'll go on hard mode now. No. Okay. Kinda crazy. But it happens. It's a functioning game though. So that's kinda cool, right? And now we move on to the challenge. I'm curious to see what the challenge will be this time. Whack-a-food. Are we doing top-down now? Is that what we're doing? Put your user interface skills to the test with this whack-a-mole-like challenge, in which you have to get all the food that pops up on the grid while avoiding the skulls. You will have to debug buttons, mouse clicks, score tracking, restart sequences, and difficulty setting to get to the bottom of this one. Challenge outcome. All of the buttons look nice with their text properly aligned. Once you select a difficulty, the spawn rate changes accordingly. When you click a food, it is destroyed and the score is updated in the top left. When you lose the game, a restart button appears that lets you play again. I'll grab the challenge. I like to do what I usually do. Want even more challenges? And look at the bonus feature stuff, because I'm always curious what they have for the bonus feature stuff. So, let's see. Easy Lives UI. Music volume, pause menu. Then they have an expert click and swipe. Instant solution walkthrough. And this tutorial can go way above and beyond. Blah, blah, blah. So, those sound all interesting, at least. Very interesting. Clicky Crates Classic. Chumbuki. I like to look at what other people made on this, just out of curiosity. Crate Ninja. It's not Fruit Ninja, it's Crate Ninja. Okay, well, we'll just save this for later, like I've been doing for the other things. And we'll get to that at some point, maybe. But let us go through with Whack-a-Food and figure out how to do this. This is another one where we'll just have the initial video, so since that will be a little bit telling us what we can expect, I'm going to just grab our challenge right now, load that up, so I can get that out of the way. Good to do, since it has to load in all the files and stuff. It doesn't usually take long, so... Weird. Import. Okay, well, I imported that stuff. Wackafoo. It's off-center. Not that I care. Of course. Why would I care that it's off-center? I mean, not a problem. It's just a little bit off-center. Anyway, I'll play this video now, and then I think I'll take a... Well, I'll just take a quick break right now, and I'll be right back. Okay. So, let's just watch this video really quick and see what we got going on.
Alright, welcome to Challenge 5. So, let's review the project that we made. So, I'll press play, we'll enter our play mode. So I can select one of these different options for my Clicky Crates game. So I'll choose easy for now, keep it nice and easy. Click the boxes, don't click the skulls, those are bad. We have the score that updates. No, the skulls, why? Okay, so our box runs out of the view, or game over pops up, we can restart our game. Let's do hard mode. Let's see how many we can get this time. Oh, no. Oh, we missed one. No. Oh, this is so difficult. Okay, so then we can change our difficulties, and then we can restart our game. So, cool. So we have all the different boxes and skulls that spawn. We can click on them. They pop with the cool effect. All right, so let's see what this challenge is all about. Now let's give our challenge a test here. So let's press play. Cool. So we got the big old whack of food here. I like these. These buttons are probably better than mine. They're so much more visible. So I like that. That's cool. Let's see. We'll do easy again. Oh my gosh, there's a timer. What is happening? Okay, I don't know what I should have done there. Let's restart. Easy. Skull, do we click that? Okay, click the skull, click the pizza. Okay, oh, so this is very similar to our last game. We're clicking things, but we click the pizza instead. Okay, cool. Pizza, more pizza. Cookies. So this is a food-based game. Don't click the skull, click the cookie, click the pizza. Okay. Let's see. What happens if we make it all the way to the end of the timer? Oh, no! I missed it! Cool. So we have this timer. Let's restart again. We'll see if we can do this wall. This is happening. We have our timer, so we can click all the different foods. This is hectic. We get score, just like we did last time. I think the food... Oh! Almost had it. So close. Okay, so I think we have a general idea. We have our food that's destroyed when we click it. We have our nice UI. This is better than my UI. We have our score here. We have our time. We lose when we miss one of the pieces of food. And then hard is definitely very hard. It's very difficult. So let's see what we're working with. Our starter project here. And already I do not like the looks of what is happening. So, okay, I'll press play. So all of our buttons... Oh, it's so bad. The easy is all the way on the right. The hard's all the way on the left. The medium is off center. Oh, man. This is a nightmare. Okay. Let's do easy again. We'll keep this easy. There's no timer this time. What? I lost already? There's not even a restart button? Okay. Let's try that again. So there's no timer. All right. So let's try this one more time. Let's see if we can see what's happening. We'll press the easy button. Do we even get a score? Pizza. Food. Oh, my gosh. Oh, it's destroying when we mouse over. I don't even have to click. Well, that's kind of cool. Okay. Oh, I missed one, apparently. Oh. Okay, so I think we have a general idea of what's happening here. So, for your fifth challenge, we have a whole slew of problems. First, as soon as the player starts the game, our difficulty buttons look really messed up. We need to fix that for sure. None of the text is centered, so it looks very bad. Our second problem, our food is being destroyed too soon, which might not really be a problem, but we'll say it's a problem for now. So instead, the food is destroyed when the player mouses over it, which is fine for the food, but probably not okay for the skull in retrospect. So we need to make it so that everything's destroyed when we click on it. Our score is being replaced by the word score. We don't even have, the score updating. We don't even have time, so that's really broken. There's also no way to restart our game, which is just very frustrating. And then our last problem, the difficulty buttons don't actually do anything. So we need to make sure that those are set up properly too. And then for our bonus challenge, our game can go on forever, so we should add a timer in. To see our bonus challenge in action, if we play our game, you can see that we have that timer text. And you can see that it counts down. And then eventually it'll hit 0 and the game will be over and we have our high score. So, now that you know all of the problems that you need to fix, now that you know the bonus challenge that you can do if you want to take your project a little bit further and stretch your knowledge of Unity, if you get stuck along the way, remember that there are hints for each of the different challenges. So, if you need help, or if you just need to remember something, you can use those hints. Very helpful. And don't forget, in your project, if you go down to the Challenge 5 folder, under the Instructions folder, is that helpful little video. So, if you need to remember exactly what you're trying to recreate, you can play that video and see all of the different parts, like the timer and clicking on each of the different pieces of food, all of the particle effects and everything. With that, I'll let you get started on Challenge 5, and good luck!
Okay, so we got the disaster of Trainwreck info on our challenge here. As usual, I don't have to do the challenges. No one's forcing me to do the challenges. It's just probably a good idea to actually do, so I know what I'm doing. At least to some extent. I got crackers. It's always good. So, we imported that stuff already, so that's all fine. So, now we'll get to the main issues here. The difficulty buttons look messy. Center the text on the buttons horizontally and vertical. That isn't really a big problem. Definitely do it. Wait a second.
Challenge is all about.
How does he make his go up? You just center. I knew that. Center. You can find your center at the end of the map reveals. It's only legendary till someone proves it real. The food is being destroyed too soon. The food should only be destroyed when the player clicks on it, not when the mouse touches it. Now, I mean, that's kind of cool, though. Like, okay, so let's see. We have destroy object. We have difficulty. We have game manager, which isn't even shown as a game manager. I guess because it's named something else, though. We have an extra thing in here called destroy objects also, which is not like our stuff. How are you doing this? There we go. Okay, so targets, difficulty button, game manager. I like to try and orient my display like I have my other stuff. Food is being destroyed too soon. So the target X would be where we want. When the target is clicked, destroy it, update score, and generate explosion. En masse enter. If game manager X is game active, destroy game object, explode. Okay, so I'm just gonna run this really quick before I change it, just to see how this is. Okay, so we don't have to click in general, we just mouse over it and it gets destroyed. In general. So we would want to change it to down, right? On mouse down. On mouse down. Then we want to destroy it. So we saved that. Let's see if it works. So now when you click stuff, it should be destroyed. Okay. When we're clicking, it gets destroyed. Not clear why it's making the game over, but when we click, it gets destroyed now. Score is being replaced by the word score. It should always say score blank with the value displayed as score. Oh yeah, I didn't even pay attention to that. How is score looking? Oh yeah, it's changing score to that. Score text. Okay, that's all fine. I didn't have a space there. Let's see. Score text equals score. Score text dot text. Score text. And the score text is text equals that. Let me make sure. Update score. Yeah, and we want a plus score. I don't know if it'll actually track the score, but it should not change that to the wrong thing now. Oh yeah, I didn't make it uppercase. Well, it is calculating the score now. It's still giving a game over immediately, but... Okay, there we go. Now when I hit play, it should be a proper uppercase one. Yeah, there we go. Now it is correct. Okay, when you lose, there's no way to restart. Make the restart button appear on the game over screen. It doesn't say to fix it giving you the game over in like 5 seconds. It doesn't say anything about that. There's nothing about fixing the game over. Let's see. Is game active true? Active, blah, blah, blah. So this has a restart button in it, but it is not popping up. Let's take a look at this. Okay, that's centered. Looks like it's proper, prim and proper. And this is under the game over text, right? Yeah. Okay, well, it does exist. It's connected to the game manager. Game manager, restart game. Active. Okay, this one we just want to set to true. It's a simple fix. Right? then we go into other game manager. Yeah, we just wanted to set it to true. That's not a big issue. So now when we start our game back up, play. I don't know what causes it to quit. Is that if we don't hit enough or something? But now when I hit restart, restarts game, click in difficulty again. Man, it likes to give the game over immediately. Destroy game object. 2. Destroy particle after 2 seconds. What? What is this even for? What is the destroy game object thing for? Destroy game object. 2. What is this script on anything? I feel like it shouldn't be on anything, like at all. I feel like it shouldn't exist. Is game active? Did they mean to set it to the sensor? Or... what? What the heck has this script on it? What would be using this script? Is anything using the script? Why was this script made if nothing is using it? Difficulty button, difficulty button, difficulty button, event system. I don't know why it would have this. That is not what I meant to do. So I don't know why this script is here. Why does it exist? Destroy object X. Destroy particle after 2 seconds. Destroy game object. 2. This doesn't do anything. As far as I can tell, it doesn't do literally anything and nothing is using it. Right? Didn't look like anything was using it. This is the cookie prefab. We got our X script right there. Target, target, target. All of them are using target. Oh. The particles all have destroy object X. Why? Where's the particle thing? particle effect is supposed to be in target, right? Particle system. Explosion particle. And we would do that on click. Right? Where is it? Yeah. On mouse down, if you press the mouse down, then it instantiates the particle effect. So on mouse down, it should instantiate the particle effect. Explode. What are you exploding? Yeah, as far as I can see, the script has no reason to be there at all. They made a method for some reason, for the instantiate method. I mean, the function thing, but that's not needed at all. So I think this is a problem here. If I just delete the destroy X object, does it get rid of all the stuff that hasn't? Does it not redo that? I mean, it looks fine to me. Open, save. I'm not sure how you're supposed to save these. And just control S it. Does that count? I guess it counts. I wonder if it's if you like misclicking them a certain amount of times. The difficulty buttons don't change the difficulty. Spawn is always way too fast. When you click easy, the spawn rate should be slower. If you click hard, the spawn rate should be faster. Okay, and that's in Game Manager, correct? Game Manager. Or was that in Target? You're spawning the target. Index spawn rate. But it's just running this whole script. Down, update, random spawn. Particle system. Oh, right. We're setting the targets in the index to spawn. And then the target in the index uses the script that's attached to it. Okay, yeah. That's right, that's right. It generates random square index 0 to 3, which determines which square target will appear in. Update score with value from target. Game restart. They have their random spawn position in here, though. But we have that. We want to just get the index. Spawn target. Field, index, random range, targets count. And then we have the instantiate targets. I forgot I still have this game running. Let's see. So we're in a game manager. We do not have a spawner. This game object, target prefabs. Oh, we do, never mind. They're all here. I'm blind. Okay, so they are all targeted. So it is using that, but we want the spawn position stuff in here. Generates a random square. Generates a random spawn position based on a random index 0 to 3. So isn't there a redundant spawn thing going on? These both have the same thing. So that seems weird. Isn't that exactly the same? Yes, it is literally exactly the same. So I'm just gonna take this and delete it. And it doesn't need to instantiate it, it just needs to instantiate that. Forgot parentheses. Should be slower if on easy mode. So, public difficulty. Difficulty 1, difficulty 2, difficulty 3. Okay, those are correct. Set difficulty. We want that. That's public. Blah, blah, blah. Game object title screen, restart button. Active, game over text. Okay, we wanted to define the start game spawn rate. Do you have a spawn rate in here? So we go under our start game. The spawn rate is equal to 5 right now, which already does not make sense. That says it's the hardest it can be right away. Difficulty. I want to set this. Difficulty. So now it should. No argument given. That. Oh yeah. It was the same thing that happened in this, right? Okay, there we go. Now it should function. I think. Space between square. Never used. What? Game active. Public part. Space between squares. Feel like I can just set that to a comment. I think it was just supposed to tell you. Was it because I got rid of that? Oh yeah, it's because those ones use it, that's why. I can just get rid of this whole thing. I don't need that whole section there at all. Because I got rid of it. Because it made it redundant. It's only used on something else. So we'll do easy this time. And now we should actually be able to hit things for real this time. So it must have it when you like miss twice or miss once. Let's see. Okay, no, it's if you miss one time, it's done. You can't play anymore. You miss it once, you're over. You're donezo. Just like in Naruto. You're donezo. Okay, so we made the difficulty correct. The game can go on forever. At a time, display that counts down from 60 in whole numbers and triggers the game over sequence when it reaches 0. Okay. I can do that. We'll create a UI, Text Mesh Pro. Create a time text. Name it time. Center it left. Okay. I guess that's supposed to be it. Try to have it matching. Man, I hate that writing. So we got score and time there. And now we want to add a time display that counts down from 60 in whole numbers. Counts down from 60 in whole numbers. So I'm actually going to look at the thing for this, because I don't really know how they would want me to do it. Hint, Google Unity countdown timer. See hashtag. It'll involve subtracting time delta time and using the math round method to display only whole numbers. Well, since it tells you your hint is use Google, I feel like it's a safe bet to use Google. Okay, so let's look. Bonus challenge solution. Timer text. In Game Manager Access, in Start Game, set your new timer text variable to your starting time. Okay. So that makes sense. We're putting in the start game, we want time left equals 60. Wait, this doesn't say, oh wait, no, it does. No, that makes sense. I'm a dummy. Yeah. Didn't save it. Why is it still not here? Why can I not see it? Why can I not see it? Oh, do I have to do it on there? I don't think you do, right? Yeah, it's not on this one. Should just see it. I think it's because of this. I think it's because of the error in one. No, it is, like, I'm writing in the right place, right? Making it public. Oh, wait, no. No. No, I don't know why it's not doing it. Oh, okay, now it's there. Was I just blind? I might have just been blind. I might have just been blind. Anyway, end start game. Set your new time. Timer text variable. Your starting time. Okay. And then under updates, do we even have an update? Don't have an update. If game is active. Minus equals time dot delta time timer text and set text. Plus Math F. Round. And left. And then another if. If time left is greater than, well, if timer left is less than 0. Then game over. Oh. So set your new timer text variable to your starting time. Guess. Yep. Okay. I just made the time left thing a public float. Since I define it as a number, I figure that's fine. And time usually goes in decimals, so I think it would make sense with a float, but not sure. They say inconsistent line endings. I guess I will just quickly do, where is our edit? Don't know if that helped at all. Don't think it did. Okay, hit start game. It looks fine still. The timer starts counting. Can we do it? Can we get a high score? Think we can manage? Yeah, they pretty much were telling you that you were going to figure out the timer thing on your own. Because they didn't tell us how to use the math round junk stuff yet. So what could we do with that, you know? You can do it. You can get through. You can get a high score. Though I suppose if it just ends the game abruptly when we get to the end. You can still see your score. Can you get higher than 290? Didn't think so. Okay, well, that was helpful. Mark step is complete. We did it. Yeah. I did that too. Provided aha moments. Sure. Swap out your assets. No. I won't. I won't do it. With course library. So they're just saying, here's all our assets that you can just steal if you want. So they're pretty much just saying you can create your own junk. Hi versus Low Poly Asset Store. Real quick. Oh, brother. How do I want to do this? I want to make sure I remember this junk. So I'm going to go in here. Make this another 3. We'll name it... Game Manager. Super game. I just want to take some of these so I can see them myself. Yeah, these already have notes on them and I know it works now, so I'll just take this one. Okay, then I want difficulty. I'll just write where I'm getting them from. This is from the clicker game also. But I want these saved so I can just reference them at another time if I'm trying to make my own stuff and go like, oh, well I made this on a clicker game, but I can use it for this other game. Targets to get clicked on. Okay, there we go. I have those scripts down. I'm gonna mark these all as complete. I'm not too worried about the personal project stuff still right now. It's not a big deal for me right now. But the quiz, that is something else. I like to try on the quiz. Okay, so that challenge I actually felt pretty good about too. I actually was able to do everything and understand the logic fine without having to... I didn't really have to reference my own document that much, besides just going like, this isn't how I did it before. I guess I just feel like I wasn't as dumb handling that one, regardless if I was or not. Anyway, this quiz will assess your ability to do everything that you learned in Unit 5. Anyway, question 1. Question 1. I like how they always asks this same thing over and over again. Which of the following follows Unity naming conventions, especially as they relate to capitalization? Well, it's a void. And it's an integer. I think it's 1. Those are lowercase. The multiply and score are uppercase because they're the name of the method. You get the parentheses, the integer is lowercase still. You're using a variable, parameter, whatever thing. So that's lowercase, that's uppercase. Section it off, put your brackets. Couldn't be this one because those are uppercase, both of them. Couldn't be this one also because the M isn't uppercase there. You could think it would be 3, but the void is capitalized and you don't want the void to be capitalized, so it's definitely 1. I don't know why my voice is suddenly going. If there is a boolean in script A that you want to access in script B, which of the following are true? I see what you did there. You need to reference You need a reference to script A. In script B, the boolean needs to be public instead of private. The boolean must be true. The boolean must be included in the update method. Boolean in script A that you want to access in script B, which of the following is true? I mean, you need to set it to... You need to set it to public instead of private, right? The boolean must be true. Must be included in the update method. That's definitely not true. I think all are true. Boolean must be included in the update method. Well, it's not included in the update method here, so that one's not right. So it can't be anything with 4 in it. So all and 3 and 4 is not correct. That means 3 isn't correct. So that means it can only be 1 and 2, or 2. And there's nothing with only that. I guess it could be 1, 2, and 3 also. But we know it's not 4. So since we know it's not 4, it gets rid of 2. But then we still have 4 left to look at. But we know it has to be 2. So it has to be something with 2 in it. And all the ones with 2 in it have other things in it. So that means we have 3 to pick from now. But it has to be 2. So that means we know it's not 1. So it can't be anything with 1 in it either. So that just means it has to be 2 and 3. The boolean must be true, and the boolean needs to be public instead of private. That seems wrong, but I'll click it anyway, and we'll see what happens. It seems wrong, but it has to be. It has to be 2. Right? Because if it was private, then you can reference it, right? I don't know. I don't know anymore. What is programming? Which code to fill in the blank will result in the object being destroyed? Starting name equal player. Bool is dead. Float health is 3. Oh geez. This one is Why do they only use 5? I guess because it counts 0. So it'd be, you know, it'd be 0 and then 1, so that'd be 5 altogether. So if you want -1 to be dead, then I'd have to count that. So all of them start with name. So if your name equals the player, and the player is dead, and if it is not equal, or is equal, true, and your health is greater than 5, destroy the object. Or if the player, or if the thing is named player and is not dead, and health is less than 5. If your health is less than 5. Your health is greater than 5. Your health is less than 5. These all sound weird. But there's only 2 that say to make it true or false. But wouldn't you be defining it true or false? But those are both greater thans. It would have to be less than, right? I'll just say this first one, even if it's wrong. We'll find out. You run your game and get the following error message in the console. No reference expectation. Object reference not set to an instance of an object given the image. And code below will resolve the problem. Get component. Game manager. Wait, no, that wouldn't be right. In the hierarchy, rename game manager as game manager. Yeah, this would be what you want. That would fix it. Confusing me for a second there. Read the Unity documentation below about the onMouse drag event and the code beneath. What will the value of the counter variable be if the user clicked and held down the mouse over an object with a collider for 10 seconds? It's called when the user has clicked on a GUI element or collider and is still holding down the mouse. On-mouse drag is called every frame while the mouse is down. So it's calling an integer, its counter, it equals 0. If the counter is less than 100, then count up. Isn't the plus sign just adding 1, though? But it's adding to itself until it's equal to 100, right? But it's over 10 seconds. We don't know how quickly it's going to. Called every frame while the mouse is down. Well, how many frames happen in a second? If the user clicked and held down the mouse over an object with a collider for 10 seconds. It would just be 100 then, right? I would think. Maybe I'm wrong, but based on the code below, what will be displayed in the console when the button is clicked? Button. Who's got the button? Start. Button, get component button. Button on click. Add listener, display welcome message. Debug log, button is ready. Void, display welcome message. Debug log. Welcome plus first name plus Smith. Welcome, Robert Smith. What will be displayed in the console when the button is clicked? Maybe this then. That's typed correctly. Capitalized and stuff. That's correct. You have declared a new button variable as private button start. But there's an error under the word button that says error CS0246. The type or namespace name button could not be found. Are you missing a using directive or an assembly reference? What is likely causing that error? You are missing using Unity UI from the top of your class. That be the type or namespace name button could not be found. Are you missing a using directive or an assembly? Oh yeah, that would be it then. And it even says using right there. Look at the documentation code below, which with following lines would not produce an error. Public void add force position vector 3 position force mode equal force mode force. Parameters force vector in world coordinates, position in world coordinates. Description applies force at position as a result that will apply torque and force on the object. Public vector 3 explosion, vector 3 start, pause, float, speed, start speed, and then start, add force at position, force mode impulse, start, pause. Okay. Would not produce an error? Which would not produce an error? Line 4. Line 4 would not. 8, 7, 6, 5. 8, 7, 6, 5. It needs 2 vector 3s no matter what. But that would definitely give an error. That would definitely give an error. So it would have to be line 8. If you wanted a button to display the message hello when a button was clicked, what code would you use to fill in the blank? Private button. Who's got the button? Button equals get component button. Button on click, add listener. Send message, debug log, hello. If you want a button to display the message hello when a button was clicked, what code would you use to fill in the blank? What code was it again? So we would just use send message, right? Wouldn't I only need parentheses? Because it has the debug log. It would run the send message script in the end listener. So I would only need send message. But it doesn't have the parentheses. So I feel like this quiz thing is dumb enough that it would tell me that it's wrong. But I mean, it's technically right. They just don't have the parentheses there. But I feel like they're going to tell me that's wrong because it doesn't have the parentheses there. And then they're going to randomly say, it's actually quotation marks hello. Or string hello. It's like, no. No. I feel like if you put the hello there, it wouldn't work. But I'll do that. Which of the following is the correct way to declare a new list of game objects named enemies? That is a good question. I haven't used a list very much. Game object. Well, list has to be capitalized. Has to use the less than and greater than. Game object should be big. And yeah, then it's just enemies. Aren't these two the exact same? Oh, that uses an S. So it's 4. It'd be 4. I think I got 2 wrong. Oh, I got 3 wrong. So what was this one? You always need a variable reference to the script you're trying to access, and that variable must be public. You need a reference to script A and script B. So it was 1 and 2. It was 1 and 2. It was 1 and 2. Which code to fill in the blank? Well, at least I got 2 right. That means I got part of the answer. Which code to fill in the blank will result in the object being destroyed? I suck at tests, though. It's like I know the information or something, you know, and then I don't know the information when I'm taking the test. Or rather, I know it well enough that I could work around it if I was actually doing something productive. But if I'm taking a test, I won't know it in the moment. Compare string to functions are needed. Oh, I forgot about that. I'm stupid. This one I don't even need to read. I didn't realize I didn't have 2 quotes. I mean, 2 equal signs there. I wasn't paying attention. Well, actually, let me just read that again really quick. By default, booleans are false unless declared as true, and adding an exclamation mark before checks that it's false. Since health equals 3, checking health is true. Did I ever write down that booleans are always false? Not declared? I don't feel like I did. Booleans by default are false unless declared. Yeah, I feel like that's actually good to remember. So this was the other one I got wrong. I got the name one wrong, really? What was wrong about it? Oh. Of course, I'm stupid. That's right. I said the quotes thing. Okay, so that was just a dumb mistake. I could see it all red there, and I say it incorrectly anyway. Well, at least I did pretty decent on that. So that's nice. I could have done worse. Could have done worse. Mini product evaluation. Do they actually make me submit anything here, or what? This is a lot of reading this time. This is actually all reading. Never mind. I'm going to take another little break then, and I'll come back to this in a moment. So I'll be right back. Okay, let's get reading. In a funny voice. When you create a real-time 3D experience, or any other experience product or service, parentheses close, it should address defined users' needs based on research with your target users. Okay, I'm not going to do that. User testing and feedback is an opportunity to reality check your project against the user personas you created during pre-production, and ideally with real people who review your designs, prototypes, and real-time 3D experience throughout the development cycle. Okay. What is user testing and feedback? The purpose of user testing is to gather qualitative and quantitative information about how well your design and its current implementation is meeting the user needs that experience is designed to address. In other words, testing the product as an experience. That's cool. I feel like I don't care. If I make a video game, it's not gonna be for anyone but me. If I'm not satisfied by it, then I'm not gonna give it to anyone else. So, if I'm meeting my expectations, who cares about the other people? If I was actually making this stuff for like a job or something, that would be different. Why conduct structured user testing? It's not ready. I'll show this to people and get their feedback when it's done. But by the time your project is polished state, it's likely you won't be able to make big changes that the feedback might bring to light. Instead, test early and often. So why would you not be able to change it? After everything I've just done on these several things, even if they're little mini games, you could definitely go back and change them all right now. I'm guessing, you know, obviously I've seen the player code that I have. for a first-person camera. And there is a lot to it. There's a lot going on just for the player thing. Or like, it feels like it's a lot, but it's not really all that much. Like, how much lines of code is this? It's probably like 50 lines or so, give or take. 400 words across like 3 pages. There's several methods and stuff, but it works very well. And I don't know. I feel like you could change a lot of things gameplay-wise and stuff pretty easily if you really wanted to. And that's usually where updating comes in. I suppose if you have a lot of moving... Well, I don't know how AI works, though. So I don't know if you can change that as easily as player control stuff, but I don't know. The user testing process typically follows this high-level structure. Define the objective. Plan the session. Facilitate the session. Evaluate the results. Okay, weird. Planning for user testing. Define the objectives. Prepare the questions. Plan the testing session. Okay, that's pretty cool. Prepare yourself for the run session. Observe the rather than guide. Don't explain or justify your design choices. Don't problem solve during testing. So this is, what? This is when you have beta testers come in? If I go ask my friends on Discord to play my crappy, walking simulator game, what do I tell them? Give me feedback. I won't try and correct anything. Immediately after the testing session, you should make sure the session was recorded, if applicable. Write down any additional notes or observations. Debrief with fellow team members, if applicable. Create a summary document highlighting areas to address. Determine what you will and will not change based on the data and feedback collected. Exercise mini product evaluation. Before you finish this tutorial, take a moment to put yourself in the role of a user tester. You just need an open document, a scrap of paper to record and organize your thoughts. To do this, choose 1 or 2 products, digital or physical. They're particularly well made, for example, a gamer software, particularly good user experience, or a kitchen implement that's stylish yet functional. Try to identify why you like the product so much using the following questions. Blah, blah, blah. Okay. Share your experience. I won't. Leave a comment. Leave a comment if you shared your experience. Summary in the next steps. Why not try planning and running an informal testing session with fellow creators for your next portfolio project? You might be surprised at the insights you get. I don't have a portfolio, though. What's a portfolio? I'll just say well-structured, I guess. Next steps, the introduction. A video introducing the final section of the course, where you learn to prepare for the Unity Certified exam, and to complete and share your own personal project. Okay. I wonder if they actually give you, like, anything to get into this exam. I don't know if I would try to go out of my way to get certified in a Unity exam, though. They give you the little badge certification, but that doesn't really matter too much, you know. But let's listen to this anyway.
If you're watching this video, it means that you have completed the course. Congratulations, that is an amazing accomplishment. You've gone from beginner to now being able to create with code in Unity. So, you're ready to continue working on your own projects independently and expanding your skill set along the way. There are probably a ton of other features you're still hoping to add to your personal projects, like sound and visual effects, new power-ups and gameplay mechanics, a user interface to tie it all together, and all kinds of other features you've imagined. To help you with this, in this final section of the course, I'll show you some really helpful tips for using the Unity documentation and other online resources to figure things out on your own. In addition to that, I'll walk you through some suggested next steps if you're interested in putting your skills to the test on the Unity Certified User exam. Most important though, you should be really proud of yourself for getting to this point in the course. You have learned and created an astonishing amount, and if you wanted to pursue it, you are well on your way to a career in interactive development. I hope you had as much fun taking this course as I did teaching it. Congratulations again, and keep on creating.
Oh, I didn't mute my mic. Oops. But yeah, all I hear about people say is like, oh, I'm a software developer. Of course I'm always depressed. Like, I don't really... I don't know how I feel about that stuff. It sounds like software development is like a bane of existence sort of thing. Like, it sucks. Object pooling. In this lesson, you'll learn about a variety of different techniques to optimize your project and make them more informative. You may notice a huge difference in these small prototype projects, but when you're exporting a larger project, especially one for mobile or web, every bit of performance improvement is critical. Several of your prototype projects will have improved optimization, serving as example for you to implement in your personal project. Okay. So let's see what we got then. Now, I was already using serialized fields before for other stuff. But let's get into it.
In this course, we've only ever used public or private variables, but there are a lot of other variable attributes that you should be familiar with. Now, I have prototype 1 open here, and actually what I'm going to do is instead of going anywhere in my scene, I'm going to go to my scripts. So I'm going to open up the scripts folder, and I'll open up my player controller script. Now, in my player controller script, I have all of these private variables. And if you remember, private variables can only be used within this class, and they can't be seen inside of the Unity editor. If I select my player object in my scene, in the inspector, underneath that player controller script component, you can see that none of the variables can be seen. In Unity, we actually have a very helpful variable attribute that you can use to see any private variables that you want to interact with. So I'll go to where my speed variable is created, and if I type a left square bracket, capital S, and write the word serialize, no spaces, capital F for field, and then I use a right square bracket. So now we have this serialized field attribute on our speed variable. What exactly is this doing? Well, if I save my script, and now when I open up Unity, you can actually see that under my player controller script with my vehicle selected, you can see that this speed variable pops up. So serialized field is a really helpful way of defining which variables you want to use just in the editor, but you don't want to ever use in a different class. So for example, if I have another class, another script that was using player controller, I want to be able to change the speed value in Unity, but I don't actually want to change that speed value in the script that's using player controller. And so that's a really helpful way that you can use serialized field to just edit variables that you just want to use in Unity itself. Just to show Another variable that we can do this with I'll also add this attribute to the turn speed. Make sure I save, jump into Unity, and now you can see turn speed can also be seen here. Now, if I open up my follow player script, in follow player, I can actually add this serialized field to our offset. Save this, head back into Unity, and select my main camera. You can see now I can actually see that offset from my follow player script, and I can actually change this to whatever values I want. In fact, if I actually play this here, so now our script is running, I can actually move my camera to get different perspectives. So that's just a very helpful way of being able to change any of your variables without using public. Other cool things that I can do is change this private keyword. So originally we had public as another variable keyword we could use, which means that we could see this variable in any other script that used player controller. You can also use the keyword protected. And so protected is a mix of private and public. So with private, I can use this variable in this script, in this class, but I can also use this variable in any other script that actually inherits from player controller. So for example, player controller inherits from mono behavior. And so you can think of start and update both as protected methods, allowing us to use them in our player controller script. However, if we made a brand new script that didn't inherit from mono behavior, we wouldn't be able to use these methods. So protected allows you to see variables or methods outside of the current class, but only to any script or class that inherits from this main class. Other keywords that we can use as well are words like const. So in this case, private const float speed. And const is just short for constant. And so that means that we can never change the value of speed because of this keyword. So for example, I could not write speed equals 10 and start because speed is a constant variable that can never change. Other keywords that you can also use are words like read-only. So when you first instantiate an object and use the read-only keyword, you can set that variable when you create that object, but then you can never change it ever again, versus const is defined as soon as you create that variable. And static is another keyword that you can use if you want to have something like a global variable to use anywhere in your code at all times. So I highly recommend looking up what the different keywords like protected, private, public, read-only, const, static, serialized field, see what they all do, try to use them in your code, and try and do some exploration yourself. So what you're going to do is open up your prototype 1.
Oh, well, that is some interesting stuff. You're gonna keep making me like open up other projects because that would be kind of annoying. No, it seems like this is just going over just some little stuff so we get a better idea of some of the other concepts.
In the course, we only ever use the default update and start event functions, but there are others you might want to use in different circumstances. In prototype 1, you can see we have our start and update functions that are used when our game is started and then run while our game is playing. So when I press the play button in Unity, any objects that have scripts will then use our start method, and then as our game starts to play, it will start using our update method. To learn more about why these different event functions are important, we're going to make another camera. So I'm going to right-click on my main camera in my prototype. I'm going to duplicate it. So now we have main camera 1. I'm going to actually rename this to be secondary camera. So this will be the camera I use when I want to get the view right in front of our vehicle. I'm just going to disable my main camera by selecting it, going all the way to the inspector and clicking on that little blue checkbox. So now it's unchecked and it disappears from our view. You can see the camera preview went away. So I'll select my secondary camera. Now you can see the view here, and I'm going to put it right in front of our vehicle. To do that, I'm just going to actually drag it into position here based on my camera view. There you go. So that's kind of cool perspective. You can kind of see the hood of our vehicle. And now I'm just going to take those values in the transform components and change the offset values from our follow player script. So now if I press play, and as I move along, you can actually see as I'm driving this car, it's actually starting to jitter a little bit back and forth. And that definitely doesn't look very good. I could probably actually reposition this camera, but we'll keep it for now. And then as I run into these boxes, you can see the weird effects happening as I hit the boxes and actually colliding with them. So this is where knowing how to use event functions is incredibly helpful. Now, there are 2 event functions that we need to pay attention to. And this is all important for our update method. So update is one kind of event function. However, if we actually type the word fixed before update, we now have the fixed update event function. Now, fixed update is especially useful when you are trying to do movement and physics. Fixed update is actually called before update calls and actually happens when our game is trying to calculate any kind of physics that is happening when we're playing it. So if I save that, we'll then go into our follow player script. Now we're going to do something very similar to our update method, but instead of using fixed update as our event function, we'll use late update. Late update is particularly useful when we're trying to calculate the camera's position. And so you typically want to use late update when you have a camera that follows the player. That way our camera knows that all of the calculations for our player's movement is done, so this is definitely where our camera should go as the game is updating. Now if I save this, head back into Unity, I'll press play again, and now you can see that our camera, from this first-person perspective, isn't really moving around anymore, which is awesome. It's not doing that shaky back and forth motion. And you can see when we hit these boxes, we're getting less of that rumbling effect when we're hitting them, and it's a lot smoother as we hit each of these different crates. So those are 2 powerful ways that we can just make our game a little bit more optimized. One last thing that we can do is in our start method, just to see a different method we can use, we can actually use another method called awake in place of start. And so start is useful when you have certain objects that are supposed to do something as soon as the game starts. However, there may be certain objects that you want to only do something when you want to use it. So for example, if you want a wall to move, you could use the awake method. So somebody presses a button, it will then call the awake method for that object, that wall, and then it will do something. So if there's certain values that you want to make sure are created when an object wakes up versus when the game starts, you can use the awake method. We're not actually going to use start or awake at all, so we can actually just remove them. That way our code is a lot cleaner. We'll save our follow player script. In player controller, we'll get rid of our start method. And so that way we don't have to get confused when we look at our code and see that we have two empty methods that aren't doing anything. So what you're going to do is in prototype 1, you're going to select your main camera, right click and duplicate it. So then you'll create a secondary camera. Make sure to rename it. We'll then make sure to disable our main camera. Now with our secondary camera, we want to move it into a position where it's kind of in a first-person view right in front of our truck. So in this case, I put it right in this windshield over here, so that way we have a cool effect over the hood. Once you've repositioned it using the transform property, you can then reposition it using the follow player script by changing the offset values to that position. Give your game a little test. Just see how the vehicle moves as you're driving through the scene. And then in your player controller script, you're going to remove your start method, rename update to fixed update, and then in your follow player script, remove start again, and then rename update to late update. And then test it once again back in Unity by seeing your secondary camera and watch how smooth the camera is. And then if you want, you can disable your secondary camera and re-enable your main camera. Now it's your turn.
Well, did that, I guess. The late update thing we already learned in that, so that was kind of weird that they mentioned that again. But okay, I'll just close out of this, close out of that. Save everything for this other one. Close out of there. Save this also. Close out of that. Telling me to open project 2, so I'll just start doing that now while I play this video.
Throughout the course, we've created a lot of prototypes that instantiated and destroyed objects during gameplay. But there's actually a more performant and efficient way to do that called object pooling. So first you're going to open up prototype 2, and we're actually going to create a backup of our project. So I'm going to go up to the top menu, select assets. I'm going to export package. Export. Now I'm actually going to export this package to my Create with Code folder. I'll call it prototype 2 complete, and I'm going to click save. Now, we'll actually be overwriting a lot of our old work to use this new system. So it's important to make a backup first in case you want to revert back. Now, the idea of object pooling works by creating a reusable pool of objects, a set number of them, that can then be activated and deactivated as they are created and leave the scene, rather than instantiating and destroying our objects, which means that our computer actually has to do more work to create a brand new object and then delete it. So using object pooling is much more performant by just having a set number of objects and then activating them or setting them inactive when we don't want to use them. In order to do object pooling, we'll actually import the object pooling package into our project. So on the webpage for this tutorial, you should see a direct download link for the object pooling Unity package. Make sure you download it. Now, you can add the object pooling Unity package any number of ways. I'm actually just going to do it using the assets option in our menu, going down to import package, custom package. In my downloads folder is where I saved that object pooling Unity package. So I'll select it and import it, and you can see that there are a couple of changes happening with detect collisions and player controller. So now if I go into my scripts folder, you can see that destroy out of bound is here, object pooler is here, player controller has updated. So first we're just going to double check and make sure that all of our different objects are set up properly. So you can see because of the change we made to player controller, it actually removed our script. So we just reapply that. On spawn manager, our spawn manager script is fine. And we're actually going to add the object pooler script to the spawn manager. So I'm going to left click, drag it, and I'll just drop it into the inspector. So you can see here now that there's a similar thing happening where we have pooled objects, we have objects to pool, and we have an amount to pool. We won't worry about the pooled objects right now, so we'll just collapse this option. The object that we're going to pool is actually our pizza. So if I go to prefabs, I left click and drag pizza onto that little slot. And now I need a number of pizzas to pool, so I'll press 20. So now when I press play, oh, interesting. It looks like we're getting some errors down at the bottom here. That's kind of weird. Let's see. So the reference script on this behavior is missing. So it says the animal dough, and it actually says it for all of our different things. Let's see. Interesting. So we're missing a script here. Now, from what I can see, we have our move forward and we have our destroy out of bounds, but we actually don't have the detect collision script anymore, so I'll drag it onto there. See if I select this moose, so they're all missing it, so I'm just going to apply all of these real quick. So now we can detect collisions. So when I press play, you can see in the spawn manager now, there's actually this expanding arrow that you can see all of the different food that we're pooling. And I'll go off to the side, and I can actually, you can see as I'm creating all of these pieces of food, it's actually setting them active and then setting them inactive as they leave our scene. And so now, we're not just creating and deleting an infinite number of pieces of food. We're only using as many as we need to use. So that way they're all created when the game starts. And then we don't need to ever delete them because we're just setting them inactive, but the player doesn't know any different. Now it's your turn. So you're going to open up your Prototype 2 project. You're then going to create a backup by going to Assets in the top left, exporting package, export. Select a place that you want to export to. In this case, I'm actually exporting into my Create with Code folder, and I named my backup prototype 2 complete, so that way I know I finished it. Once that's done, I downloaded the object pooling package from the tutorial webpage. I imported that package into my project. Once I imported that package, I saw that player controller and detect collisions were both updated. As well, object pooler and destroy out of bound were both added as new scripts. In player, I made sure to add player controller back as a script onto that player object just to make sure it works. I selected my spawn manager, added object pooler as a script, set object to pool as our food prefab, and then for amount to pool, I set that number to 20.
Alright, I need to take a second on this one. Not the pool. Want it.
A handful of other things I needed to fix. On each of my different prefabs, the detect collision script unattached itself. So I needed to
Why am I, why can't I see it?
make sure that I selected each prefab and then added detect collisions as the script to use. Once I saved, everything should be working.
Hmm.
So then when I press play, if you take a look at your hierarchy, you can see that Spawn Manager now has this arrow next to it with 20 different pieces of food. And then if I.
Wait, did I forget to attach the object pool to your spawn manager? Oh. Wrong thing. That's what side bounds array. What? Oh yeah. It reset the speed. Does this food have the spawn manager on it?
Deactivated as they are created and leave the scene. That object pool, you can see that on spawn manager, different objects are set up properly, so you can see because of, and I'll just drop it into the inspector. You can see here now that there's a similar thing happening, but the pooled object all pressed.
When it's spawning an animal, it's having some issue. I'm not sure why. Yeah. It's the food that's doing it. The food is going outside of the array. Oh, it was just because I had the spawn manager on it for some reason. I don't know why I had that on there. Not sure why I had that on there. Not gonna lie. Do not remember why I did that at all. Either way, done with that part. We're happy. We know it. We clapped our hands. Do they still want us to work on these other projects more? In this lesson, you will attempt to add a speedometer, an RPM display to your vehicle in Prototype 1. In doing so, you will learn the process of doing online research when trying to implement new features and troubleshoot bugs in your projects. As you will find out, adding a new feature is very rarely as simple as it initially seems. You inevitably run into unexpected complications and errors that usually require a little online research. In this lesson, you will learn how to do that so you can do it with your own projects. Well, I didn't expect this to teach more like that.
In this lesson, you'll attempt to add a speedometer and RPM display for your vehicle in Prototype 1. And in doing so, you'll learn the process of doing online research when trying to implement new features and troubleshoot bugs in your projects. As you'll find out, adding a new feature is very rarely as simple as it initially seems. You inevitably run into unexpected complications and errors that usually require a little online research. So in this lesson, we'll learn how to do some online research so that we can do it on our own for our projects. Now, one thing that'll set our driving game apart from our driving simulator is by adding something like a speedometer to be able to actually track the speed of our vehicle, much like you would see in a car itself. If we're going to implement a speedometer, the first thing we have to do is make the vehicle accelerate and decelerate more like a real car, which uses forces as opposed to the translate method. Because of the fact that translate will actually move our vehicle at a constant speed, we'll need to use forces and rigid bodies on our vehicle to make it move at different speeds, by applying different forces onto the vehicle to make it speed up and slow down. So open up your Prototype 1 project, and when Prototype 1 is open, we're going to make a backup of our project because we're going to change some of our code. So in the top left of Unity, go to the Assets dropdown and Export Package. Now I'm going to export this package directly to my Create with Code folder. So I'll call this Prototype 1 Complete. Now I'll make sure to save. So now that we've saved our Prototype 1, if you remember, on our player object, we have this player controller script, which is how we actually move our vehicle through the scene using that translate method. So I need to actually go into my scripts folder and open up player controller. Now in my player controller script, I have the transform.translate method where I move the vehicle, but I need to use physics and forces to do so instead of using transform.translate. So I'm actually going to create a new variable for our rigid body. And now I need to actually assign that rigid body when our game starts. So now in our start method, our player RB variable is set to the rigid body component that we have on our actual vehicle. Now, one thing I want to do is I want to actually comment out the speed because I'm going to create a different variable for applying the actual force. So in case I want to use speed and I want to use this translate method, I'll comment both of those lines out. So instead of speed, I'll make a private float called horsepower, and we'll set that to 0 for now. Since I actually want to interact with this variable, I'm going to add that serialize field attribute. So now I can actually play around with this variable in Unity, even though it's private. And then in my update method, I'm going to use that rigid body. I'm going to apply a force using the add force method. We want to apply that force in the forward direction. We don't actually need to use time.delta time since we're applying forces instead of translating something. I'll multiply it by the horsepower that we have. And then we need to actually control that force, so we'll use vertical input. So this line of code isn't entirely different from our original line. In some of our past projects, we were using add forces to move things. So now is a good opportunity to try using add force again. So I make sure I save. Now in Unity, you can see that my player controller script has updated on the inspector. So I'll select that player, and horsepower is set to 0. So what I'll actually do is I'm going to test out this variable. So I'm going to enter play mode. And we know 0 is not going to move it at all. So let's try like 10 since we had about like 20 before. So we're not really moving, but we can turn still. Let's see, what if I just if we put it to 100, does it move anywhere? No. Okay, maybe we need more force. 1,000? Still nothing. Let's go even more, 10,000. Very little movement. Okay, let's say 20,000. Oh, there you go. So our vehicle moves forward, but doesn't actually move in the direction that we turn it in. So that's frustrating. Let me make sure that I actually set this variable now that I'm out of play mode. Let's try that again, see what happens. Yeah, so the vehicle doesn't move in the right direction at all. It's just always moving forward, which could look really cool if you're making like a drifting game, but we still want to be able to turn that vehicle. So what did we do wrong? To help conceptualize the problem here, so you can see right now we have the arrows for that move tool. And right now, our move tool is actually locked into global coordinates. So we can use this toggle in the top left to switch between global and local. And so now local should actually turn as we turn the vehicle. So with global coordinates set up on our rotation tool, if I actually rotate this vehicle left to right, you can see that it actually is always still pointing down the road. If I switch to local coordinates, you can actually see as I rotate this vehicle, now the arrow is pointing wherever the vehicle points. So we actually need to figure out how we can apply forces according to our local coordinates. Luckily, the internet is our good friend here. So in Google, I actually typed in Unity add force in local space. And you can see all of these different things popped up. There's actually some Unity answers questions here. So this is actually our forum where users go to ask questions, and then other users will actually answer it for them. And then we also have the scripting API. This is actually the official Unity documentation. So you can see here we have that add force method. We know that doesn't work, so let's see. If we click into the topmost result, the question here says add force in local space, and the user asked, how do you change an add force from global to local? The top reply from this user says to add relative force instead of add force. So we were using add force before, but I don't know what this add relative force does. So you can see that the user was trying to point us in the right direction using add relative force. Down in the suggestions for the scripting API, add relative force is actually one of the options that we can select as a result. Or we can ask Google once again. So Unity, add relative force. So this actually brings up that result for our documentation. So you can see in our official documentation, the description tells us that it adds a force to the rigid body relative to its coordinate system. So So it actually is using that local coordinate system. So if I go to my player controller script, if I go down to my update method, if I just add the word relative to add force, I can save, and then I head back into Unity and I test my game out in play mode. See, as I turn, I should be moving in the direction the vehicle is pointing. So, see, that works. Our vehicle is doing some weird things at the moment. That's fine. We'll fix that in a bit. Oh, we just flipped over. But on the upside, our vehicle isn't just driving straight down the road as I turn. So using a little bit of searching on the internet and finding the add relative force method, I was able to fix the problem that I had. So what you're going to do is you're going to open up Prototype 1. In the top left of Unity, if you select the Assets menu option, go down to Export Package. You're going to export a new package to save as a backup for your Prototype 1, since we're going to change it. You're then going to open up your player controller script. In your player controller script, you can comment out the variable for your speed, and you can comment out the line where we are moving the vehicle using transform.translate. I added a new variable for our horsepower that will be applied as a force. I used that new attribute serialize field so that I can actually change this value in Unity. I needed to make a new variable for our rigid body, and then I needed to assign that rigid body in our start method using getComponent to find the rigid body of our current object. And then in our update method, instead of using transform.translate, I used player rigid body dot add relative force to move it in the forward direction times the actual force that we're applying, and then multiplied that by our actual input so we could control our vehicle again using our arrow keys. So then when you test out your game in Unity by entering play mode, you can move the vehicle down the road, and as you turn it, it will actually start moving in the direction it's pointing. Now it's your turn.
Let's see. What am I doing wrong here? Can't tell if it's moving. That time did it. So that is 1,000. That's 1,000,000. That is 1,000,000. So what if we did like 800,000? Okay, how about 500,000? I'll try 100,000 again. Yeah, wow, you need more than 100,000. Okay, so how about 300,000? Okay, that's fine. Burnt car from flipping over.
Now that we've implemented real physics on the vehicles, it's very easy to overturn. We need to figure out a way to make our vehicles safer to drive. So if I test out my game again, as I drive my vehicle down the road, at some point it just kind of flips over, and that definitely isn't great. Oh, it flipped back. That's cool. There you go. Full rotation. Cool. Land back on the ground. So while this looks kind of cool, this is not what we're trying to accomplish at all. But how do we fix this problem? We'll head back to the internet and see if anybody has any solutions for us. So I actually Googled Unity prevent car from flipping. There's a couple of things that pop up. There's some YouTube videos. There's Unity answers posts. I'm just going to check out this first link here. This actually brings me to the forums on our website. So how to prevent the car from tilting flipping. I have some problems with the car I'm creating. I have a simple car that has a rigid body, 4 wheels, wheel colliders. What is that? Using a script. Let's see, what are the responses? Lower the center of gravity of the car's rigid body. What does that mean? Okay. Let's see if there's other recommendations. So that first one was kind of helpful. Mention them about wheel colliders. Let's see what the second option says. So, car keeps flipping over. The handling is terrible. Okay. When you go through a corner, the car flips over. Let's see, what does this person say? What vehicle physics are you using? Are you using wheel colliders at all? So, wheel colliders mentioned again. You'll need to provide more information. Make a note of center of mass. Well, let's see. So this person is recommending wheel colliders and center of mass, and they provided a link. Let's take a look at center of mass first and see what this does since it's already linked. So it says vector 3 center of mass, the center of mass relative to the transform's origin. If you don't set the center of mass, it will be calculated automatically from all of the colliders on the rigid body. So maybe we can use the center of mass. I assume maybe the rigid body is setting our center of mass a little bit higher than the actual center of our vehicle, so we can try and change that. There's a little example here. Set center of mass this way. We can try play around with that. Let's see. So center of mass, and then it mentioned wheel colliders. So actually on the documentation, I can also just search what I'm looking for. So if I go to the top right, there's this search scripting option here. Type in wheel collider. Let's see. Searching. Oh, okay. Look at that. Second option, wheel collider. A special collider for vehicle wheels. That seems pretty useful. So wheel colliders are used to model vehicle wheels. Well, that will probably help a lot. So let's see what happens first. So we have these wheels. So if I select the vehicle, I can actually select each individual wheel. And you can actually see they're all children objects of our player. So I'll select this first wheel, and I'm going to disable this mesh collider by unchecking that box. So now there's no collider on this wheel. You can see if I put it back. So that looks to be a pretty large problem. So our wheels are not perfectly circle, so they have these edges on them. So our wheel will actually roll onto one of these edges, and these edges might actually catch onto the ground here. So that is probably causing our vehicle to flip over. So I'll disable this mesh collider, and I'll add a component, and we'll look for a wheel collider. Oh, look at that. So we do have a component called a wheel collider. So what if I click this? Okay, so it's like kind of like a perfect circle. It's a little too large for what we're looking for. So let's see. Maybe if we change the radius a bit. A little too large, maybe like somewhere kinda. That looks okay for now. It's still off center, so that's a problem. So we'll actually just change the Y values on the center, drag it up a little bit. So that looks, it could be a little smaller. So I'm actually just going to change this value manually. So I'll type 0.4. Still a little high. Let's see. If I do 0.39, we'll make just a touch smaller. 0.14. It's a little bit off. Let's see. Maybe if we just move the Y up a little bit, so 0.15. So that looks pretty good. Pretty close to the wheel itself. Cool. So we'll collapse this mesh collider. We're not using it anyways. So we have this wheel collider on. So I'm actually just going to apply that wheel collider onto all of our wheels. So I select the second wheel, and then I shift and left click on the last wheel. So now all of our wheels are selected. I can disable the mesh collider, add a component, and we'll find that wheel collider again. I believe our values were 0.39 on radius, and then 0.15 on center. So I'll just make sure that's correct. Cool, so first wheel, 0.39, 0.15, 0.39, 0.15. Cool. So let's see what happens now that we have our new wheel colliders. Look at that. So our vehicle doesn't stutter anymore. It's going very fast, and we just toppled over. So it kind of works. Our vehicle does a little bit of a swimming motion, and it's very easy to tip over. So at least now we have the movement down, but we want to definitely change how easy it can flip. Now that flipping problem is actually probably caused by that center of mass issue that we were having. And we looked up in the scripting API in our documentation. It had some tips about center of mass. So if we head back to the internet, and I just looked up Unity how to lower vehicle center of mass. So we have that linked to the documentation that we had before, but there's also this Unity answers problem here. So what if I select this one? So it says here that they're making a script. The driving is working, but whenever they turn hard left or right, it just starts going on two wheels. So they don't know if it's the center of mass or problem with the wheel colliders. Our wheel colliders definitely work. You can see here that they've actually posted a snippet of their center of mass. That's what the COM stands for. So this person recommends the easiest way to do this is add a child empty object called center of mass. Then in your script, set the empty object's local position to the rigid body center of mass. So then we can make it adjustable, and the script that sets that center of mass can be reused. Make sure to use that local position. Okay, interesting. So the thing they recommend to do is actually create a center of mass object as a child of this player, this vehicle. So I'm going to right click on player and we're going to create an empty. And I'll name this game object center of mass. So now we have this empty game object where we can actually control the center of mass. Now in my player controller script is where I'll actually need to set that center of mass. So I'll open that up. So we already have the player's rigid body. And according to that person's suggestion, we can actually just get the center of mass. So let's see, when I start my game, if I get the player rigid body, let's see if I just type center. Oh, there's center of mass. You can reset center of mass. So now I can actually get the center of mass of my rigid body. And I actually want to set this to the center of mass that we have. I think actually I'll need to get that game object first. So let me do this. Since I need to actually assign this in Unity, I can actually use serialize field. And in fact, I don't need to even use the word private because all of our variables are private by default. The cool thing with serialize field is now I can actually set a reference for that center of mass game object without using public. So I can just say game object. We'll call this center of mass. So now we have that game object that we're making. So we need to get the center of mass's actual position, the transform position. And so now what's happening is we're actually setting the rigid body's center of mass to the position of the center of mass object that we made in our game. In Unity, one of the last things I need to do is, if I select that player object, you can see center of mass, there's no game object referenced. I can actually take the child game object and drop it onto the player. So now if I test this out, let's see. So now our center of mass should be lower. Now our speed doesn't really move. That doesn't really work. Let's see. What if we just like change this, I don't know, 40,000. Double it again. Now we press play. Doesn't really move. Let's see, maybe there's a problem with the actual center of mass. I see, the center of mass is in the ground. That doesn't really work. So let's move it to like the bottom of the car. It's typically where the center of a vehicle's mass would be. Now if we press play, okay, it's a little forward heavy. Let's move that up a little bit, and we'll move it maybe towards the back. Oh, there you go. That is a lot of force we're applying. Oh, look at that, but we don't flip over. That's cool. So originally, in fact, if I select the player, our center of mass was somewhere around here, actually where these arrows are coming from. So using this center of mass game object, I moved it a little to the back and a little bit down to make it a bit more accurate as to where the center of mass would be. Now in our player, we were still moving too fast. What if I set this back to 20,000 again? We test this. So it doesn't really work. Maybe 30,000. That way we're not accelerating very fast. As fast as 40,000, but we're still moving. There you go. So it looks like there's a small issue where the vehicle gets stuck. I'm just going to move this vehicle. So what's probably happening is the wheels are actually clipping into the ground, so that's where it gets stuck. So if I press play, the vehicle, because of gravity, will fall to the ground. And there you go. Now it's much smoother as I drive around. And there you go. We're flying off the screen. So still too much force applied. Let's just bring it back down to 20,000 again. And still not enough. So somewhere between 20,000, 30,000 is probably a good number. We'll say 25,000 for now, see if that works. So that looks a little bit better. We could do a few things, like we could actually change the mass of our vehicle to be even more. So instead of 1,000, we set it to 2,000. So that flip should definitely happen way less. We actually applied too much mass, so the force isn't enough to move it. So you can change a couple of different things. You can change the mass, you can change the horsepower, and you can change the actual location of the center of mass, and that will make it easier to move your vehicle around. So play around with those different variables. So what you're going to do is on your vehicles, you're going to select all of the different wheels, disable those mesh colliders, add a new component for the wheel collider. Make sure that radius lines up with those wheels as best as possible, and then maybe move the center so that it's actually the center of the wheels. You can then create a new empty game object called center of mass. Make sure you make it as a child game object of the player. So you right click on the player game object in the hierarchy, go down to create empty, and then it will create the center of mass right at the center of the vehicle. If you head into your development environment, you can then create a new variable called center of mass. So that's the game object that we made. And we'll use serialized field so we can actually assign it. So in our player controller script, we need to add that center of mass. Now that we have the vehicle in a semi-drivable state, let's display the speed on our user interface. In order to do so, we need to add a Text Mesh Pro object to our scene, much like we did with projects before. So in the hierarchy, I'm going to right-click in the empty space, go down to UI, and go to Text-Text Mesh Pro. Since I haven't added Text Mesh Pro to this project before, I'm going to need to import it. Now that it's imported, I can exit out. So now we can see in our scene, we have our vehicle, but we can see the white outlines of this Text Mesh Pro canvas. So I'm actually going to select that canvas and press F. So now it zooms out so I can actually see very far zoomed out. So if we get our canvas in frame here, you can see our little game world here in the corner. And then we have our Text Mesh Pro canvas here. So if I press play, you should see that little new text pop up probably on the bottom, right about there. So that doesn't look good at all. So we're going to have to actually adjust that. So first what we're going to do is with the actual text, we're going to rename this to our speedometer. And we want our speedometer to have probably a position in the top left where our player can see how fast they're going. So first I'm actually going to change the anchors to be the top left. And now I'm going to move the text over to that corner, right about there. And then for the text, I'll just say speed for now. Now if I press play, we should see speed in the top left corner. Cool, so that looks pretty good. Not going to change any of the text for now, for the fonts or anything like that. I'm just going to leave it as is. In this case, since we just want to see our speed working, we're not going to use a game manager script. I'm actually just going to use my player controller script, since that's where I can actually see the speed that our player is moving at. So in the player controller script, I actually need to create a variable for that Text Mesh Pro text. So in fact, I actually need to import that library first. So at the top of my script, I add a using statement for using TM Pro. So now I can find the Text Mesh Pro library. I'm going to create another serialized variable like this game object. This time I actually need the actual text. So I'll get the Text Mesh Pro UGUI and call it speedometer text. So now that I have this variable, in Unity I need to make sure that I actually attach this text to the speedometer text. So I'm just going to click and drag on speedometer and drop it in there. So now we have a reference and I can change the text when I need to. Now the question is, how do we actually calculate the speed of our vehicle? Once again, we'll head over to the internet and see if anybody has any questions for us. So I looked up calculate vehicle speed, and one of the first answers is how to get car speed. That seems like what I'm looking for. So let's see, this person has a car that can move and they want to get the speed. Okay, so it says here, so for car speed in kilometers per hour is speed. So I guess we need a speed variable again. We set that to the magnitude. So we can actually get the velocity that our rigid body is moving. So that's very helpful. And then in this case, they multiply by 3.6. That's a pretty good start. So we can actually just use this rigid body.velocity.magnitude. And velocity will actually get us the actual velocity, the speed that our vehicle is moving. And the magnitude gives us the number. So that was pretty helpful. I did notice as I was going through the results that there is another result about a car with wheel colliders. We do have wheel colliders, so let's just see what this person says. Making a simple car driving game with the GUI text. Cool, that's exactly what we're trying to do. The speed display doesn't seem very realistic. This person has this little formula here. Let's see what the reply is. So simply get the speed by using, there's that rigid body velocity magnitude again. Oh, so it returns the speed in meters per second. So that's what you get when you're using velocity. So to get the speed in kilometers per hour, oh, so you multiply by 3.6. So that's why the 3.6 was there. If you want to get it in miles per hour, multiply by 2.237. Oh, okay. So because when you're going from meters per second to kilometers per hour, you have to do a little bit of math to get the proper number of how to convert meters per second to kilometers per hour or miles per hour. So that's actually what those numbers are. You don't need to do calculations using wheel colliders. Okay, cool. That's pretty helpful. So since it said we needed to make a speed variable before, I'm actually going to uncomment out our speed variable. I'm actually going to turn this into a serialized variable as well. Since our speed is actually being calculated now, I don't actually need to set it when I start. Now, in my update method, I probably want to calculate my speed after I apply that force. So if I do speed equals player rigid body dot velocity dot magnitude, then we want to times it by, I think it was 2.237f. That way our program knows that that number is a float. Just for our own sake, if we want to change it to kilometers per hour, so for kilometers per hour, change 2.237 to 3.6. Okay, so now we're getting that actual speed. So now we just need to actually set the text for our speedometer. So if we do speedometer text dot set text, we need to make a string so we can say that this is the speed. And then we concatenate the actual speed that we're calculating. And then just as a nice touch, we'll add another string at the end to say miles per hour. So now if I save this, hopefully, now our speed should update in the top left when we play our game. Okay, well that's very weird. My speed is moving very fast. I think I actually still have my vehicle set to be very heavy. Let me change that really quick. Up 2,000, I believe it was 1,000 before. Let's see, so now we play, and we can move down the road. And there you go. So you can see it's changing. There's a lot of numbers after the decimal point. And in fact, when we press play, you can see that it actually starts giving us a number value because it's falling to the ground. So that doesn't look right. Also, it's kind of small. We should probably make that a little bit larger. But let's fix this problem first, because this looks very weird. Just all these decimals. So how do we get rid of these decimals? Well, the decimals happen because this number is a float. And to get a round number, we actually need an integer. So how do we get an integer from a float? So let's head back over to the internet and see what it has to say. I looked up how to convert float to integer Unity. The first result that popped up is this mathf round to int. So returns f, so that's the float rounded to the nearest integer. Let's see. So float f, so that's the number we're passing in. And then it gives you back f rounded to the nearest integer. Okay, so it looks like this is how you would use it. So mathf.round to int, so then you put in the float, and then it gives you 10. Okay, So mathf.round to int. Well, let's see if that works on this little formula that we have here. So I'm actually just going to apply this here. So let's see, mathf dot round to int. Then I guess we just want to put this entire number in here. So now if we save, so now we should just get whole numbers. There you go, just says 0. Should probably make that text box a little bigger. There you go. Now it's just whole round numbers, so that's good. So that works great. So we'll fix that issue with the size later, but that works. For a fun little fact, if you remember a few lessons ago, we were talking about different keywords you could use on variables. Things like const, read only, and static. You can actually see we have a const variable here for our turn speed. And this is actually down here where we're calculating our speed, a case where you can actually see a static class. Actually, in fact, up here as well. And so if you remember, in cases like our rigid body, we have to actually create a variable for that rigid body and then assign it to something. But for things like input or for math, we don't actually need to instantiate anything to use these classes. That's because they're actually static. And so static allows us to use different classes without having to create an instance like player rigid body for a rigid body. So what we're going to do is in prototype 1, you're going Another cool feature that a lot of car simulators have is a display of the RPM, or revolutions per minute. The tricky part is figuring out how to calculate it. First, what we need to do is create a new text area for our RPM. So in my canvas, if I left click on that little drop down arrow, so we have the speedometer here, I need to right click on canvas, and I'll create another UI Text Mesh Pro. Now it's somewhere off in the distance. Let's see if we can get, there you go. So you can see it's in the center of our canvas here, and we need to actually move it to the top left, about here. I'm actually going to set the anchor first, so it's in the top left. Then let's see, what line is that at on the Y? X is 135, so I think if we just move this over, there you go, so it's all lined up, so that looks nice and clean. And here we'll change this to RPM. To avoid that problem we had with the speed before, with wrapping, we're going to set this to disabled. And now we can get our RPM. Let me make sure that I rename this element to be RPM. Now I need to actually create another variable for this. So in my player controller script, right after the speedometer text, I will create a new serialize field text mesh pro UGUI. We'll call this RPM text. And now I need to make sure that I set the RPM as a reference. So in Unity, if I select my player, I'll drop this RPM text element down into the RPM text. So now we have the RPM text, but we need to actually calculate the RPM. So let's see what we can do. So the internet will be another helpful resource here once again. So Here we need to calculate the RPM of our vehicle in Unity. So we have all of these different options. We'll check out this Unity answers question. So this person is making a speed limiter. Wants to do this through wheelcollider.rpm. That could be interesting. The problem is we would have to get a reference to one of our wheel colliders and then see what that does. Let's see what this person says. If you want to get the speed, you should know the circumference of your wheel. Multiply it. Okay, let's see, what are they doing down here? Speedometer, put your wheel radius. This seems a little too complicated. We're just going to maybe do a bit simpler of a whole calculation than this, but this is a generally helpful start. You can see they're actually doing the conversions from the RPM to the speed, which is kind of cool. So in order to get our RPM, I'll make another variable, and just so we can see what it's doing, we will make it a serialized variable called float RPM. So now we actually have to do some calculations for our RPM in our update method. So that person used RPM to get to speed, so we can use our speed to get to our RPM. So we'll make our RPM variable. And RPM is generally a pretty large number compared to our actual speed. So if you're going somewhere around, I don't know, like 80 miles per hour, maybe you get like 3,000 RPM or so. So we'll just say like speed. And in this case, we'll just create our own little formula and just kind of show you a cool symbol that you can use. So if I type shift on the number 5, I get this percent symbol. And just for the sake of seeing what it looks like, so speed percent 30. So the percent symbol is a special kind of operator in C# and in programming in general, called the modulus operator, or what you may be more familiar with, the remainder operator. And so this means that we are actually dividing speed by 30, and then it will actually give us the remainder value. So if speed were to be 30, and then we divide by 30, we actually get a 0. If we divide speed, which is 31, divide that by 30, we actually get a 1. And so this is just kind of a cool way that we can kind of wrap our numbers all the way from 0 to 29. So let's save. And in fact, we actually need to set this RPM in our RPM text. So we do RPM text, set text, RPM, plus RPM. So now we save. Let's check out our project, see what happens when we press play. So now we should just see it go from 0 to 29, and then it goes back. So that's cool. However, 29 is definitely not a very high RPM. So we'll make this a little bit cleaner. We'll actually just wrap this entire little equation with parentheses, so that way this operation happens first, and then we multiply this times 40. Let's save. Now let's see what kind of numbers we get. Okay. It's kind of as if, like, when you're going through each of the different speeds, you're actually kind of shifting gears in a way, resetting the RPM back down every time. Cool. So what you're going to do is create a Now that we have a mostly functional vehicle, there's one other big bug we should try to fix. The car can still accelerate and decelerate, turn and increase in speed and RPM in midair. So how do we make it so the vehicle only moves when it's on the ground? Once again, we'll head over to the internet to see if there's any solutions. So I looked up how to test if wheels are on the ground in Unity. And there's a couple of options here. There's Unity Answers, which is from a few years ago. Could work. There's one from 2005. There's the official documentation. We'll take a look at the documentation for now. So it says that there's just wheel collider is grounded. It's a Boolean that says if it's grounded, indicates whether the wheel currently collides with something. That seems like it's good enough to get the job done. So first what we need to do is we actually need to get all of our wheels as references so we can actually track them. So I am going to create a new list of wheel colliders in my player controller script. So I need to actually assign these variables, so I'll serialize this. We'll call it a list. We need to make it a type of wheel collider. And we can name it all wheels so we can keep track of all of our wheels. So now that we've added that list to our player controller script, we do actually need to set the size of this list. In this case, we have 4 wheels, so we need to set the size to 4. And now we drag in each of our wheels as different elements. So that's the front left wheel, this is the front right wheel. This is the rear left, and this is the rear right. So now that we've assigned references to all of our wheels, we'll need to create a new variable. And just to see how many wheels are on the ground, we need to keep track of the number of wheels. So we actually need an integer. So we'll say int, and we'll call it wheels on ground so that we can keep track of the number of wheels that are on the ground. After our update method, we'll create a new method, in fact, to keep track of the number of wheels. So we'll call it void, and we'll just call it the count of our wheels. So we need to keep track of the count of our wheels on the ground. So we use wheel on ground. We set this to 0 because we'll assume that there are no wheels on the ground. Now, a cool thing that we can do with lists is something similar to the way that we used for loops to iterate through something before. So with for loops, you could set the end condition of when the for loop would stop. With lists, we can actually use the for each loop. So we type for each, and then we actually use parentheses. Now in our for each, we need to tell it what we're trying to find in our list. So we're trying to find wheel colliders. We need to give a name to that wheel collider. So we'll just call it each wheel that we go through. And now we need to give it the list that it's actually going to go through. So in all wheels. And then after this, we put curly braces. So now we're in our for each loop. So what we're going to do is if each wheel, and now we can use the is grounded attribute. So if our wheel is grounded, wheels on ground plus plus. So just to think about how this will work, when we call the count wheels method, it will go through each wheel in our list of wheels. So the front left, front right, rear left, and rear right wheel. So maybe it goes through the front left. That wheel is not grounded. It will not add a number to the wheels on ground. Front right, that is grounded, so it will add 1 to wheels on ground. Rear right, also grounded, so it will add another one. Rear left, not grounded, so it will not add 1. So then we're left with 2 wheels on ground, the right side wheels, but not the left side wheels. Now, this could be useful. However, what we're actually looking for is to know when our wheels are on the ground. We don't just want to keep track of the wheels on the ground. We actually want to know when our vehicle is entirely on the ground. So I'm actually going to change this method a little bit. So void doesn't actually give us any value back. So we actually need to return a value, and we'll actually return a bool. And instead of count wheels, we can just say is on ground. So now if I call the is on ground method, it should give us back a true or false. True if all 4 wheels are on the ground. False if none of the wheels are on the ground, if less than 4 wheels are on the ground. So now we're keeping track of how many wheels are on the ground. So we can actually just use another if statement. So if the wheels on ground is equal to 4, if all of the wheels are on the ground, we return true. and keep doing whatever we want it to do, else we return false. So if less than 4 wheels are on the ground, then we don't want our vehicle to move. So now that we are keeping track of whether our vehicle is on the ground or not, in our update method, we should actually prevent the player from being able to move when they're not on the ground. So in fact, I can actually just wrap this entire statement here in an if statement. So if is on ground, parentheses here, delete this, put all of this in parentheses, in brackets, I should say. So if is on ground returns true because all of our wheels are on the ground, then it will update our forces, rotate our vehicle, and give us the RPM. Otherwise, it will return false, and we won't be able to move our vehicle. So if I save this, pop back into Unity and press play, now I can move the vehicle, and then you can see that my speed and my RPM stop because I left the ground. So what you're going to do is in your player controller script, you're going to create a list of wheel colliders called all wheels. In Unity, in your player object, under the player controller script, an all wheels variable should appear. Make sure to set the size to 4, and then make sure to drag each different wheel into each element. So the front left, front right, rear left, and rear right. Once you've done that, create another variable to keep track of how many wheels are on the ground as an integer. You're then going to create a new method that returns a Boolean value called isOnGround, where you'll set the wheels on the ground to 0 initially. You will then loop through the all wheels list by using a for each loop, and you need to use the syntax for each wheel collider wheel in the all wheels list. Inside of that for each loop, just do a check to make sure that the wheel is grounded, and if it is, to increase wheels on ground by 1. So that way, if the wheels are on the ground, all 4 of them, you return true, otherwise you return false. And then in your update method, you're going to wrap your place in your code where you apply forces, rotate the vehicle, and set the RPM into an if statement that checks if the vehicle is on the ground. Then you can do all these things. So then you can pop into Unity and test your game and see if your script worked. Now it's your turn.
Okay, so I'm doing this one at the same time. I got some problems here. Let me go through this and see what I got going on. So I got split, I got that. We got the list, wheel collider, all wheels. And we got wheels on ground also. The player, we have the center of mass position, blah blah. Then we have the fixed update. There's 2 inputs. Everything else is an if statement. Is on ground, parentheses. That should all be the same. And then we go down to our bool. And all code paths return a value. Okay, so wheels on ground equals 0. Then for each wheel collider, the wheel in all wheels. All wheels. Make sure I read them right. Then if wheel is grounded, wheels on ground equals plus plus And then if wheel on ground equals 4, return true. Oh, was this the problem? Oh, that was the problem. I didn't have my other bracket there. And that bracket didn't need to be there. Oh, the only actual problem I had was the brackets. So, the wheels too messed up or something. Huh. Looks like it's getting stuck on something again. Let me just try and turn this up a bunch. Again. Okay, what if I elevate you very high? Well, I can't drive when I go off the map. It seems like the tires are probably getting stuck. It does work. But I think the tires are getting like caught or something. I did use a bus instead of a truck like the other folk. I don't know, but it does technically work. I can't accelerate further when I'm in the air, so technically works. Messed it up a little bit, but you know, it happens. It happens. You learn how to build your projects so that they're playable outside of Unity interface. First, you'll install the necessary export modules to be able to publish your projects. After that, you'll build your project as a standalone app to be playable on Mac or PC computers. Finally, you'll export your project for WebGL and even upload it to a game sharing site so that you can send it to your friends and family. Okay. Install export modules. I already know how to do that. I'm good with that. Build your game for Mac or Windows. Let's close that out. Close that on. I mean, the clicker project was kind of the cooler one. but I guess I could use the other one. I don't know. Anyways, quick parsing, resizable, window, quick build name, projects, you build, rebuild it in different settings. I'll just say okay. I don't need to do that one. I understand how to do those things already from the Essentials course. So I'm pretty okay with that. I feel confident to not need to look at that. You learn at very high level about Entity Component System and how it is different from typical object-oriented or component-based system. Probably familiar with if you're preparing to take Unity Certified User Programmer exam or just want to know ECS is at a very high level. This will be a very helpful tutorial. Rather than being structured around objects or components, code is structured around key pieces of data, move speed, player health. The benefits of this new system is that it allows for an extreme improvement to performance and optimization previously thought not possible. What does it look like? Okay, well, let's take a peek at the future, I guess.
Now, Aaron, the people at Unity have been coming up with some stuff of their own, and I see that we're running short on time.
Yes.
So let's just have a very, very quick overview of a thing that you can't really do a quick overview on.
Yes,
which is
it would be my
DOTS and
pleasure.
ECS.
Okay, so two acronyms here, DOTS and ECS. And it's intentional that we've only left a few minutes to talk about this because we only want to give you a very high overview of what this is in general and sort of what to look out for, just to be aware of if you see it. You really just need to understand at a very high level what this is. You don't actually need to be able to use it. So could you click to get the bullets up here, Jacek?
I will.
So DOTS, the first acronym, is short for Data Oriented Technology Stack. Okay, and it's basically a stack or a bunch of technologies that come together to make Unity much, much more performant. We're speaking of optimization here. And it's basically an entirely new way of thinking about your code, thinking about the way you structure your project in a way that will allow you to make much, much more complex games that run smoothly on different devices. So just quickly, the three things that make up this stack are what are called the C# job system, entity component system, that's where ECS comes in, and the burst compiler. You don't really need to understand the C# job system or burst compiler. Those are a little bit more complex. I want to focus on this entity component system and sort of what that implies. And specifically, just at a high level, what does it mean for something to be data-oriented? This is the data-oriented technology stack. Basically, rather than structuring your classes, your code around objects, like for example, we had an enemy class or a player class, or around components. So for example, we had the move forward script, or we had the destroy out of bounds. Those are kind of component-based or object-oriented design when you think about how your code is structured. This is data-oriented. And what that basically means is you're structuring your whole project around data, key data points that are going to change in your project. So for example, the speed of your enemies, maybe that's going to change a lot. And so you structure your code in a way that is really focused and based on what data is in your project and what data is going to change in your project. And that might be confusing. That's okay. It's totally okay right now. And also, this is still in development right now. So this is not really ready for you to use in a really easy way yet, but Unity is working on that. Could you go to the next slide, Jacek? Just want to show people the power.
Yeah, so why is it that you would use this system, I hear you ask? Well, here is a little GIF of a project running the Unity Megacity demo project. So this uses the DOTS and ECS systems to take full advantage of multi-core processors. Now, because this is a GIF, you might be seeing some lag. I do recommend looking up on YouTube the Unity Megacity demo. Because the GIF is lagging, I'm just going to skip to the cool bit. It's a car that you can control flying around a giant city, which is made up of 8 million triangles, 6 million unique entities, and has 2,000 cars flying at all times at a stable 30 frames per second. So that's a lot going on within just one scene, with a huge GIF as I'm seeing people. So I do recommend looking it up. However, I hear you say, now this is pretty cool and neat, Aaron, and I agree. But what if with this ECS and DOT system, we could make this 8 million triangles, 6 million entities, and 2,000 cars all work on a mobile phone? Well,
What?
with this system, we can, my dear friend, because it is just that ridiculously optimized. Now, once again, we do not recommend currently using this. This is still in development. We just want you to be aware of it. And it is super cool technology that I can't wrap my head around still. So, Aaron, I'm just going to show a snippet of code because as you can see, it's much different than code that we would write.
Right. So this is 2 examples of how code might look. And I just want to draw your attention to a couple of key features that you can recognize in this code so that if you see some code online, you can say, oh, that must be from a DOTS or an ECS based project. So you can see in the imports, the using lines up at the top, you can see that they're using the Unity entities library. And that's critical right now in order to actually make this run. So you need to import a whole bunch of new libraries. But another really great way to recognize it is that all of the classes that we've done up to this point, all of the scripts have inherited from, so if you can see that little colon at the top on the left, it says public class movement system, job component system. So anything we've written up to this point has inherited from mono behavior. And that's the sort of standard Unity component-based system that we've been using up to this point. Or on the right, it says inherits from iComponent data. So you need to inherit from totally different classes, import different classes, and you can also see on the right, it's using a struct, which is much different than anything we've done up to this point. You don't need to know what that is, but just be aware that you'll see very different things in a ECS-based design than you would the component or object-based design that we've been doing up to this point.
Yep. And once again, so the name of that project was Megacity. I believe it is also available for download. So if you want to try it out at home yourself, you should be able to find it out there on the internet. Otherwise, there is a whole bunch of DOTS and ECS learning material. But as we said, this is very advanced features that honestly, as someone who's been writing code for quite a few years of my life now, I am not ready for it quite yet. So just be aware it is out there. It is cool if you're interested. Definitely give it a go. But otherwise, it is very, very...
Huh. Well, all right. Absolute beginner application scripting. So got that done. Completed in this project. Got through all that stuff. All structured and based. That's fine. Okay, where are we going next? What we got next in here? I don't know how long this section will be. In this tutorial, your research career areas, job titles, and the necessary certification qualifications to help you identify... I forgot to turn back on this. Oops. Not that it matters much. I forgot to turn on the lip sync, but it's not that good anyway. but it looks like this might not be that important. Always check right away. Do they ask me to submit anything? Okay. Gotcha. You might have previously explored different kinds of career possibilities. Consider the right roles for you. Junior programming analysis. Feel like I would never want to do any of that. Unity offers a variety of certifications to validate that you have core skills needed for a variety of roles and to showcase your readiness for your next career move. Certification is not required to get specific job roles. Whether or not you get certified is entirely up to you. However, it's useful to understand what's available so you can determine whether a particular certification would help you get a job. But you don't need it. Validate your foundation. Professional. Expert. Certified expert programmer. I don't know if I would want to try and get into any of those things. What do employers look for? Create a career research document. Yeah, I'm sure it's good. I'm doing it right now. Trust me. I'm not doing it. Yeah, it was fine. I understand what they're doing. It's just, that's not what I'm here for. I'm here to learn how to make my dumb video game. Your review, goals, and uses a portfolio. Plan your own portfolio using a flowchart. Begin to select and organize content. Physical books containing samples of an artist's work. I mean, I got a bunch of short stories online. They're all like smut and fetish stuff, but I'm sure someone would like them, right? For hobbyist game developers, itch.io can be seen as a portfolio page where you upload our various games you made, share the game jams you have participated in. Yeah, itch.io seems like a place that I'd probably submit like a walking simulator if I actually make it, you know. If I actually make one that seems interesting. Most portfolios share similar features. Portfolio introduction provides an overview of your skills, training, career, interests, goals, and blah blah blah. And manage narrative, download option, full portfolio, bridge version. Research some great portfolios. So pretty much have stuff where people can see your work. Which it seems like Unity offers with the WebGL thing, but I mean, I guess itch.io would probably be a better place for it. I understand. Create your portfolio. Yeah, I'm definitely creating it, like, as we speak. I mean, I guess you could say I actually did that, right? I technically created one. Unlock these rewards. Is this just going over what I learned? You'll build a prototype of your own design that uses a provided counting functionality. Or I guess they're telling us to use a functionality, but create whatever with it? Maybe? I'm just thinking I'm still not done with this stuff. Like, I just started this part, but just real quick. Just gonna hop over to pathway thing. Oh wait, no. I think I do look under this, don't I? just wanted to look at this thing. Manage scene, apply object. Okay, it's not letting me click on that part. We did all this stuff. .1. I don't understand. Is it not saying that I did this already, or is it saying I did this already? Beginner, 2 hours. That's my mission right now. I don't know why this thing takes forever to load. You didn't program their stuff very well. Assessments completed. Assessments completed. So I didn't do the assessments. I wonder what they consider the assessments. Manage scene. That's supposed to be me up there going through it. I'm just kind of curious how it's looking, I guess. And I guess it's looking like that. Well, I'll start on the other stuff later, but we I was gonna stop after that section, and we finished that whole section. We got through Unit 5. We learned more about the user interface. We learned how to make a menu screen. We learned how to make a game over screen. We learned how to make some counters. No, but we learned quite a bit. And I think realistically we could probably make a little baby prototype now, but it seems like we still have more to learn. I mean, there'll always be more to learn, but we're gonna learn how to count next. That'll be fun, maybe. I'm not sure if they're going to start doing like more hands-off approaches for these next prototypes, but I guess we'll find out. If they do, it would probably be better for me to learn that way, since so far it's pretty hand-holdy. And even if it takes me longer, it would be just helpful to be able to solve it myself. Even if it takes me like 5 hours to figure it out. But you never know. Anyways, I'm gonna go for now. So for anyone who came over to learn with me, thanks for watching. Hope you enjoyed. And we will see you on the next one. So bye.